For all those who appreciate the work that we're doing here on Standing for Truth, please hit that subscribe button because we are just getting started.
Are we live now?
Yeah, I think so.
Yes, we are live. Real quick, I just want to... Okay, there we go. Get rid of that. So yes, we are live and kind of the spur of the moment stream, but it was Friday night and I just couldn't help it. So we got some good people together. Right now we've got a rational empiricist, David Neff, the debate addict himself, and Godzilla freak. So this is going to be a lot of fun. Thanks for joining us, gentlemen. We've got a couple of creationists, a couple of evolutionists here to battle it out. Just kidding. Just a friendly dialogue. What I'm going to do is, I see people coming in and out of the backstage, is we're going to open it up maybe in like 40 minutes. For now, we'll keep it just us four. We've got a couple things to discuss in terms of universal common descent and the so-called heat problem associated with the flood, just to pump people up for next week's rematch between David Neff and the film free, the sequel. They are going to be debating the Genesis flood once again. David Neff has actually converted to young earth creation, and Neff has converted to evolution. So David, from my understanding, you're going to be taking the position of the flood, and Neff is going to be debating you against the flood. Isn't that right?
Yes, that is absolutely correct. I am now a fundamentalist Christian and a young earth creationist.
There we go. And what a coincidence that as you converted to young earth creation, Neff converted out of it. So this should be fun. I'm just kidding. I'm sure people know. So next week, I'll plug that in. We've got, let me look at the schedule here. So next week on the 26th, the global flood, the sequel, Nephilim Free versus David Neff. Tomorrow, we've got a debate on the gospel, original authorship, with Jefferson and Gavin Hurleyman. That's at 9:30 EST, so that should be a lot of fun. And next Thursday, we've got Joseph Hubbard back with us to discuss the global flood, limestone, the fossil record, and a few other topics. Mostly, we're going to be doing an audience Q&A, though. It's going to be a rapid-fire Q&A, so please bring your questions for Joseph Hubbard. That's going to be a lot of fun. And at the very first week of March, we're having Matt Slick back on to debate Derek Barnes on Christian morality versus secular morality. So that's going to be a lot of fun as well.
Yep.
And I'm sure we're going to be having David Neff and Matt Slick. We're going to be getting them in on a second round as well.
Oh yeah, and Matt confirmed that he wanted to debate me on the messianic prophecies.
Oh, he did confirm with you?
I was asking if he confirmed with you because I would love to debate him on the messianic prophecies.
It seems like it's usually every few weeks he's open to doing another debate. So we had him on for Dr. Ron Garrett. Snake was right. Now Derek Barnes, and I think we'll hopefully be able to set that up between you and Matt Slick, maybe in the middle of March. You're a busy boy, David. You got a lot of debates coming up, so you better be drinking extra coffee. All right, let's
bring him on. Bring him on. Bring him on the debate.
I'm an addict too. I feel your pain. I feel your pain. So, anyways, enough for me. We've got Rational Empiricists here. Of course, David Neff, Godzilla Freak. Everybody introduce yourselves at the exact same time. Go ahead.
Hello.
Hello, everyone.
Yeah, I'm Godzilla.
All right. Now that we are all well acquainted. Just kidding. So how's everybody doing tonight? Not partying too hard, I hope.
Yeah.
Try to stay warm.
It's fine.
Yeah. Is it cold where you're at?
It's freezing. Snow everywhere.
The snow will get you. Yeah, it came down pretty hard for us. About 4 days ago, I got stuck on the way to get a coffee because we all know I'm addicted to coffee, and I got stuck. And I spent so much time getting unstuck. I never did get that coffee. So yeah, it's been rough around here, but discussions like this are going to make things a little better. So. Why don't we get right into it? Godzilla Freak, he's a creationist as well, like me. Rational Empiricist, he's been here, no stranger to this channel, nor a stranger to discussions. David Neff, of course, no stranger to debates. And same with you, Godzilla Freak. So everybody's well known. We don't really need any introductions. Why don't we just kick it off here? Maybe Rational Empiricist had a question, or David Neff wanted to start it off. Godzilla Freak. Whatever comes to mind.
I'll let David go first. Since he had something.
I think for us, we actually had it like 2 weeks before everyone else because we live pretty far up north and then Calgary, right? It's like Western Canada. So we actually had it really cold 2 weeks ago, and we're just starting to warm up where everyone else is sort of freezing over.
Yeah. So you're already past that. While we are all just experiencing the pain now. Yeah, because you're in Calgary, right?
Yeah.
Awesome. Well, I will say this. So what kicked this off was Rational Empiricists. We had a debate. It's got to be going on a few weeks now. A couple weeks. I don't know. Time goes by so fast. Specifically on nested hierarchies and cladistics. We titled it, common descent. Design or dissent. So we enjoy these types of dialogues, friendly chats, keeping it cordial. We will be having a second debate on that or discussion in the future. This is kind of more spur of the moment. So that's kind of what started this. And then David, being a debate addict like myself, we were discussing the flood and the heat problem. So I think for now we'll focus on those issues. And then eventually we'll open up the room, and you never know where these open mics head towards. So we'll keep it fun. Whoever wants to start, go ahead. David, you might have a question. You guys are all the guests. So, I've got a million questions, but you guys are the guests. So you guys can kick it off.
Yeah, sure. So I guess I'll kick it off. I'm starting to doze off to sleep, so I'll try and stay awake as much as I can. So we're going to be, so I'm, of course, as you already mentioned, going to be debating Nephilim free on the flood. So I think the first thing we should do is try and sit down, do the math, do the dirty calculations, and try and figure out, first of all, how much heat is going to be released from catastrophic plate tectonics, from the movement of the crust, and from the flood itself. So figure out, and of course, accelerated radioactive decay. Figure out what the sum of the total, how much heat in all is going to be generated. Get that total, and then figure out what is needed, what cooling items would be needed in order to solve for this problem. So that's what I think should be done first.
Okay. So do you feel like the heat problem is then the number one argument against a global flood?
No, I actually think the genetics issue is the number one argument against a flood. But I think the heat problem comes at a very close second.
Okay. We could go to the genetic related arguments, but let's stick with heat. So when it comes to the flood, what about the heat and what about the numbers do you believe poses the biggest problem to the Genesis flood? Like, what numbers are you specifically referring to, and what assumptions are behind I guess your arguments pertaining to the heat?
All right, well, sure. So Dr. Snelling, of course, did his calculation for what the temperature is going to be for the if we had accelerated radioactive decay. We can calculate, okay, the temperature is going to be about 22,000 degrees Kelvin, which is about 3 times the surface temperature of the sun. And basically in response, he pretty much acknowledges that this is a significant problem, but kind of hands waves this away and say, okay, well, we see this evidence such as plutoniums, halos, and okay, so this might be a confirmation for accelerated decay, but this is kind of just hand waving away the obvious issue with the calculation that at 22,000 degrees Kelvin, the Earth would pretty much be vaporized.
Okay. So yes, I'm aware of the paper
and
Snelling where. Yeah, I'm sorry. Go ahead, David.
Okay, yeah, and have you ever seen the paper called "A Physical Constraints Lockean Deluge"? Have you ever seen that paper?
No. Do you have it on hand? Did you want to?
Yeah, I can
What's
share.
the significance of the paper?
So basically, these are professors from Wheaton University, Wheaton College, whatever it's called, and basically they're trying to calculate, okay, the physical issues of it. I'm going to pull up the paper here, and I'll show you their calculations.
Oh yes. Okay. Yep. I know which one you're talking about now. Okay.
Yeah. So they're calculating the rainfall method. Now, this was back in the 80s. This was well before flood geology and Dr. Snelling and all these flood models were developed. So these are admittedly a little bit dated. That needs to be updated a little bit. But the calculations are certainly there. For the rainfall alone, we can look at the calculation, how much is required to cover the highest mountains. And here's a calculation and what the temperature would be at the surface of the temperature of the Noachian Ocean. And the answer would be 6,458 degrees Fahrenheit. Of course, they say the problem is, of course, much more complicated than this, but these figures demonstrate clearly the severe thermodynamic problems that must be solved if one wishes to deal with the biblical flood in a scientific manner.
Okay. I'm going to screen share real quick too, unless there's another couple points you wanted to make in regards to that. Okay. Yeah. Go ahead. Yeah.
So these are two, I think, some of the big issues that we should talk about, whether or not this global deluge is even physically possible.
Okay, so I think though I'm just sharing screen right here, so there might be a bit of a lag, just for the time being. So I believe you're bringing up some valid criticisms that are deserving of discussion. Okay, and Godzilla Freak might have some input here. I'll start. So what you're saying is correct in terms of Dr. Andrew Snelling acknowledging the amount of heat produced, of course, just through meters per second plate movements, right, during the time of the flood, catastrophic plate tectonics. The friction alone would certainly create a lot of heat. Now, Dr. Snelling, though, as you did point out, David, he points to radio halos and fission tracks. Okay, what this is in a nutshell, and we've had Professor McQueen on for like a couple-hour show going into the technical details on what radio halos and fission tracks mean pertaining to accelerated nuclear decay. It's pretty well just scars within the rocks themselves, indicating a lot of decay in a short amount of time. Okay, we could also look to helium in zircon crystals if you'd like to, but the point is, we do see the evidence in the rocks that at some point in history, okay, decay rates were accelerated. Okay, now we have the heat associated with accelerated nuclear decay, among other things associated with catastrophic plate tectonics. Okay, so how do we deal with that? Well, for one, and this is pointed out on page 194 of Rock Solid Answers. Okay. Radio halos and fission tracks are obliterated at relatively low temperatures.
Correct.
Okay?
So
if
that
there
means
has been a heat problem due to accelerated radioactive and nuclear decay, then we should not be finding these radio halos and fission tracks in the rocks today, but we do. And Snelling pointed that out in the papers you're referring to.
And if I could respond to that real quick.
Yeah, go ahead, David.
Okay, sure. So that's a little bit of a quote mine in and of itself, but he goes on and says the following: however, the reality of the existence of the halo must not have been an insurmountable problem if there has been accelerated decay. Incredible amounts of heat must have somehow been removed rapidly by a process or processes that we have not yet discovered or understood, for otherwise these rocks and the radio halos in them would have been vaporized. So translation is Dr. Snelling is doing the calculation saying, okay, here's 22,000, the overall calculation. The temperature rise would be 22,400 degrees Kelvin, which would vaporize the radio halos and all of this stuff that he is talking about. So obviously, because we see the radio halos that allegedly prove accelerated decay, there must have been some type of cooling mechanism that has not yet been discovered. So the point of the matter is there is still a significant heat problem associated with this model. Dr. Snelling acknowledges it and says that, okay, we still need to figure out what process or processes that would be needed in order to solve for this problem.
Right. So good points, good observations. So here's the thing. What we have in the rocks themselves, observable evidence in the rocks themselves that decay rates have been accelerated. Creationists would say the accelerated nuclear decay occurred at creation and then during the flood, okay? Now the question is, okay, what mechanisms were at play to remove that heat? Okay, so we already know that decay rates were accelerated, okay? We see that in the rocks. We see the scars themselves. Now, obviously, the ripple effect of this, as you're pointing out correctly, David, and I'm glad you are, the ripple effect is immense amounts of heat produced that essentially the argument goes, and correct me if I'm wrong, this amount of heat would have boiled the oceans. Right. The radiation as a result would have resulted in the death of Noah and the animals. And the crust itself would have been obliterated. It would have melted, essentially. Is that kind of how the argument goes based on those temperatures and those numbers?
Pretty much, yeah. I think that would be a good summary.
So now we have to discuss the mechanisms, okay, that Dr. Andrew Snelling is talking about in his papers, okay? So I've got a list of possible solutions, okay? Now, we weren't there during the flood.
Of course not.
Today we see the rocks. We see the scars indicating accelerated nuclear decay. Now it comes down to plausible solutions in getting rid of that heat. Right off the bat, before I even go over these points, and then David, I'll give you plenty of time to respond. Right off the bat, okay, according to the flood model, heat itself is not a bug. It's actually a feature of the global flood. It's needed, right? Heat and energy are required, as I put here, to get the plates moving during the flood. Meters per second plate movements as compared to the snail-paced movements of the plates the uniformitarians look to, okay, the heat and energy would greatly help with that. Okay. And all we would really have to do is get the heat into space, where you've got essentially an unlimited heat sink that can absorb all that heat. Okay. So for one, I just want to point out heat isn't totally bad, as it's a feature of the flood. It's required. It's necessary. Okay.
Absolutely. And I would agree that a global flood would absolutely produce enormous amounts of heat. So we can both agree with that.
Right. Now here's my question. Okay. Based on this point here. Okay. And this comes to mind is, are these numbers making any assumptions because remember, you never want to straw man an argument. For example, you'll find evolutionists oftentimes arguing against evolutionary creation, right? When we get into the genetics, they make arguments that assume we explain the majority of genetic diversity as the result of what? Mutations. No, we look to created nuclear heterozygosity. So obviously you want to argue against the model and not a straw man. So here's the thing. Are these calculations being put forth, being purported by the critics? Are they making any essentially unknowable assumptions about, let's say, the temperature of the Earth's core in the pre-flood world?
Well, I can show you Dr. Snelling's calculations if you want me to pull it up.
Right. Okay, yeah, I've seen Dr. Snelling's calculations, but there have also been some non-young Earth creationists coming up with their own calculations too, right? Saying that right.
So
yeah, go ahead.
Right. So when I do these types of calculations, I want to be as generous as possible to your model. For example, we know that the Bible says that the water was about 20 feet above the surface of the 20 feet above the tallest mountain peak. Now, obviously, no creationist is going to say that the highest mountain peak is Mount Everest, which is almost 30,000 feet. They would argue that it was much lower.
Well, I would say this. It's kind of like, it's not exactly the same, but it's very similar to the naturalist and pressing the naturalist on abiogenesis, okay, origin of life. Now, the naturalist does not have a solution to the origin of life problems, okay? They have come up with a number of explanations, possible solutions. Now, obviously, I would respond to those solutions by saying, hey, those solutions each bring a number of unsolvable chicken and egg problems with them, okay? But that's besides the point. They will still put forth solutions, okay? They don't necessarily know which solution is the solution that possibly worked in their hypothetical scenario, but solutions nonetheless. And that's what I'm pointing out here when it comes to the so-called heat problem, is we have the evidence. We've observed the evidence actually through predictions from the rate team before they even went into it. We have the observable empirical evidence of accelerated nuclear decay, fission tracks, radio halos, and helium, just to name a few. Now it comes down to plausible solutions. As long as we can provide some plausible solutions into how, let's say, we can take most of the heat and dump it into space, maybe much of the energy and heat produced during catastrophic plate tectonics, maybe during that year, okay, maybe it's still in the Earth's core today, right? How hot is the Earth's core? But one thing I want to point out, David, and then I'll yield to you. There's something called the Hypercane model. And to me, this is very persuasive, okay? And given the effects of the Genesis flood, massive hurricanes during the flood would have actually taken up much of the heat into space. Okay, and this isn't post hoc ad hoc. I want to say this before you continue, David, because today we can see what? We can see hurricanes, and we can see how great they are at dumping heat and energy into space, okay? For example, here I've got jotted down, when a hurricane goes over the ocean, what happens? Well, the temperature itself actually drops, and not just a little bit, it drops significantly. Okay, David. So, you know, it's understood by most scientists that convection is a great way to move heat quickly. And that's all we're saying is, as long as this heat, this abundant amount of heat is moved quickly and into space, Okay, we know there would have been a lot of convection during the flood year. Look at hypercanes, for example. Okay, look at the fact that you've got a mile or more of water that can take up much of the heat. Okay, and that water can also protect Noah and the ark animals from the radiation, the excess radiation. I mean, they use water to block from radiation when it comes to nuclear reactors. So water is very good at protecting and shielding things from radiation. But here's the last thing I'll point out, and I've got it listed here. Okay, the fountains of the Great Deep. Okay, if you assume the either hydroplate model or catastrophic plate tectonic model, the fountains of the Great Deep would have actually involved supersonic steam jets that would have taken up, I would say, most of the heat up and into space. And like I said, all we have to do is provide plausible solutions as to how it's possible to dump most of the heat into space. Then essentially we don't have a problem. Now it fits like a glove. We got the evidence for accelerated nuclear decay in the rocks. And now we have plausible solutions as to how we can dump all that heat into space itself. Not to mention ice cold hail coming down and cooling off the oceans slightly. But think about a massive pool. This is the last thing I'll say because all these things are coming to mind. Think about, you got a massive pool. If you were to just dump boiling water or even just liquid hot magma into one corner of the pool, it's really not going to change the overall temperature of the pool itself much, even though that liquid hot magma is incredibly hot, right? And that's what you're looking at in terms of the flood when the entire earth is covered with miles worth of water. Okay, yeah, certain parts of the earth are going to be boiled. Certain parts of the earth are going to be incredibly hot. But for every reason why you'd have a hot spot, or for every reason why the flood is producing a lot of heat, you've got 10 reasons as to why that heat can be absorbed or removed. Now, I know I said a lot there, but it's a big topic. So I yield. Go ahead, David. What are your thoughts on that?
All right, sure. So a lot of stuff. Let's start with the idea that the water could have acted as some form of innovator, could have somehow protected Noah. And you brought up the idea of a nuclear reactor and how they use water as a coolant, correct?
Right.
All right, sure. So I have a question for you. How hot is the water inside of a nuclear reactor? Do you know?
So when we're using water in a nuclear reactor to protect and shield things, I would submit it's probably not quite as hot as the hot spots during the flood. Is that the point you're kind of getting at?
Yeah. Well, I'm just picking a number. How hot is the temperature inside the nuclear reactor? Can you at least give a number?
An exact no. I imagine you have the number in front of you. What's the number?
But let me ask you before I tell you, what would be the absolute maximum temperature for your model to work? Like, if it would be like, say, 600 degrees Fahrenheit, don't you think that it would be too hot for your model to work?
Not necessarily, because let's just say let's say it's 300 degrees Celsius, let's say, okay, in a nuclear reactor. Now, when it comes to the flood model, though, that's why I'm not giving just one solution, So I'm not just saying it's only the fact that we have cold water coming up during the fountains of the Great Deep, okay, incredibly cold water to counterbalance the heat a little bit. Also, miles worth of water during the flood, helping to shield, let's say, Noah and the ark kinds, okay? Also, the supersonic steam jets, the hypercanes, so on and so forth, the extremely cold hail coming down. It's all of these things in combination, right?
Right.
So it looks like you want to just go, you want to just take one and then kind of ignore the others.
Right. Well,
I think go ahead.
I think the best way to go about this is by, as it turns out, it is about 600 degrees Fahrenheit. That is about the temperature of the water in a nuclear reactor. Okay. So we're dealing with very hot temperatures there. The thing that we need to ask, because you brought up hurricanes and other stuff, again, I think it is important to kind of sit down, do the calculations. What is the heat problem? How much heat is going to be generated? And then we can use the models and say, okay, well, how many hurricanes need to be forming in order for there to be sufficient amount of heat that needs to be released? Let's see if that's a plausible mechanism by first going through the calculations and seeing all of just trying to figure all of that. Is this mechanism sufficient to cool this sufficiently?
Right. So what I would say is, when it comes to exact numbers, okay, now we can run the numbers based on a number of hypotheticals or a number of assumptions, but it's not just black and white when it comes to the flood model. Okay, so that would make it difficult to have exact numbers. Okay, now here's the thing.
Right. Well, yeah, I'm not asking for exact numbers.
Right. Okay.
I just want to kind of like do ballpark figures. So, okay, this is the ballpark figure under this potential model. Because again, that's not like that.
Right. So here's what I would say. I'm going to go back to this. Okay. Okay. What we observe directly in the rocks is evidence for accelerated nuclear decay. We literally see the scars in the rocks themselves, okay? It indicating that one or more periods of accelerated nuclear decay has occurred in the past. As creationists, we would say the creation event as well as the flood event. So we see that, okay? Secondly, since we see that, well, the heat and energy itself, I wouldn't even look to it as being a bug. I would say, okay, this is a strong feature of the flood. This is a necessary aspect of the flood, because in order to get those plates moving. Now, I would say this, just in order to explain the geology of the Earth, catastrophic plate tectonics, okay, meters per second plate movements during the flood, okay, picture two cars coming at each other at 100 kilometers an hour, okay? The buckling that would result is significant enough to explain, let's say, mountains that we see today, okay, to explain the geology of the Earth. But this whole uniformitarian, these processes that say it's these snail-paced movements of the plates, okay, the necessary buckling could not take place with uniformitarian processes in order to explain mountains and geological features to begin with. It would be like two cars coming at each other at 20 kilometers an hour. There's not going to be much buckling. But at 100 kilometers an hour, that's exactly what you're going to get as a result. So I would say that the catastrophic plate tectonics explains much of the geology of the Earth to begin with. Like, how would you explain, answer this after actually, how would you explain through snail-paced movements of the plates under actualism or uniformitarianism, how could you explain, mountains with that assumption? But my point is, the plate movements during the flood, accelerated nuclear decay can help that. Heat and energy can help that, okay? Now, as long as through these number of explanations, okay, the Hypercane model, ice from hail, okay, helping to counterbalance the heat, as well as just the massive amounts of water to begin with, extremely cold water coming up through the fountains of the Great Deep, the supersonic steam jets. I mean, I can go on and on with these solutions. This can essentially dump most of the heat into space. Okay, those are plausible solutions. Now we can sit down and come up with some solid numbers, okay, as to how this is going to work exactly. But the point is, we still see the scars themselves in the rocks, and that's significant evidence that accelerated nuclear decay has occurred. Yes, heat would result, of course, but here's X, Y, and Z as to how that heat can be dumped into space, or maybe much of the heat is still in the core today. Plausible solutions, a lot more solid solutions than I'm seeing from the naturalists in terms of abiogenesis. At least we're coming up with some decent solutions. I mean, the abiogenesis crowd, for every solution that they come up with, it's chicken and egg problem after chicken and egg problem. So, that's besides the point. But I brought up a few points there, David. Since you're my guest, take as much time as you need to address that. and then maybe I'll yield because maybe Godzilla Freak or someone else on the panel wants to. I don't want to just dominate. So, David, go ahead. The floor is yours.
Yeah, sure, definitely. And so about mountain ranges forming, I think pretty much any geology textbook in the world will answer that question. Basically, what happens is that and I'll just use the Himalayan mountains as an example. Basically, the Andean plates and the Eurasian plate are colliding together, and that is forming the mountains that we see that the Himalayan mountains have. And in fact, we can use GPS data, and we can see that these mountains, in fact, are still growing today. So we're going to make a couple of hypotheses going through the scientific method. So a hypothesis is going to be that, okay, plate tectonics explains the formation of these mountains. And my hypothesis is going to be that this is caused by the colliding of the two continental plates. So the prediction that it might be making is, okay, if this is the case, then we should still see this process happening today. And we can confirm using GPS data and other methods that, in fact, these mountains are still growing at a rate about 2 centimeters per year. So naturalism, the actualism, as it is noted as today, the actualism explains this quite nicely. As far as
David, how, if I could just jump in real quick, how slowly are the plates moving, let's say, per year, according to actualism?
So I think it depends on which plate you're moving, exactly which plates. I know, just from the top of my head, I know the Australian plate was actually moving so quickly that recently that they had to update the GPS systems because to account for the northward dripper, that the fact that Australia is drifting northward. Now,
right. So I would say I'm not disagreeing with the fact that the plates are moving. Okay, this is pretty well a fact, obviously.
Right.
My point is that according to actualism, okay, the plates are colliding into each other at snail-paced movements. Okay.
Correct.
So the buckling that would result from these uniformitarian processes, okay, they can't actually explain empirically the forming or the uplifting of these mountains, okay? The collision of these plates are supposed to explain the uplifting of these mountains, right? But what I'm saying is the meters per second plate movements during the flood could easily explain how through catastrophic plate tectonics these mountains are formed. That's why I'm using the example of two cars coming at each other at 100 kilometers an hour, okay? The buckling that would result, okay, is significant enough where you're looking at two cars coming at each other at 20 kilometers an hour. You're not going to have any buckling. You're not going to have anything as a result, really. So my point is catastrophic plate tectonics, which we are assuming during the flood, that is our model, can better explain the mountains to begin with. And what helps the plates move that quick? Heat and energy, which the evolutionists say is a problem. But I've already given, I think, 4 or 5 perfectly plausible solutions into how that heat can be dumped into space. Maybe some of it's still in the core today, and I don't want to repeat myself, but go ahead, David, go ahead.
Yeah, sure. So again, we know that plates movement, tectonic movements, they don't happen at a constant rate. We do know that they can speed up and slow down. That's pretty much well known. I
agree, but overall, still slow. Obviously, it's not constant, but it's also not meters per second movement of the plates, right? Like catastrophic plate tectonics would purport or propose, right? It's still overall slow. And here's the thing, though. We would assume catastrophic plate tectonics, rapid movement, okay, rapid meters per second movement of the plates during the flood. Then it would slow down to what we see today. So therefore, if we're looking at the plates moving today and assuming that that's how it's always been, okay, you know how uniformitarians will say that the present is the key to the past. Well, that's based on a very faulty assumption, because to begin with, I am purporting that snail-paced movements of the plates that we see today cannot explain the necessary buckling and uplifting of the mountains, while catastrophic plate tectonics can perfectly, actually, and leads to testable predictions in terms of these massive slabs of cool rock that have been found under North America, I believe it is, itself, through rapid subduction. This was predicted by Dr. John Baumgartner and then discovered years later when they came up with the field seismic tomography, right? So how do you explain these massive slabs of cool rock, where if uniformitarian thinking and actualism were the case, then these slabs of cool rock should have at least heated up to the temperature surrounding the slabs, or even melted, right? This is confirmation of rapid subduction just thousands of years ago. How would you explain that? And I know I went on for a while there, so I'll mute and go ahead, David.
Okay, yeah, sure. I want to give Andrew a moment to talk. So, Andrew, do you want to kind of try and answer that real quick?
Yeah, I guess I unmuted because I actually had a question for you, Standing. So I guess I'm not entirely familiar with the concept of catastrophic plate tectonics, but I believe it only goes back as far as say the supercontinent Pangea. Am I correct in that assumption?
That's a very good question, actually. If we went into the technical details of catastrophic plate tectonics, we would actually put the pre-flood supercontinent as being Rodinia, and then Pangea actually being a temporary supercontinent during the flood, during catastrophic plate tectonics. And even the uniformitarians look to Rodinia as a prior supercontinent to Pangea.
Right. Or I guess I would say there's also, according to uniformitarianism, been previous supercontinents and other continents before Rodinia even, right?
But then that is actually based on a number of assumptions, unknowable assumptions, essentially, that we could get into. But I will say this, to expand on what I was saying, in that our model that says Rodinia was your first supercontinent, Pangea, a temporary supercontinent, okay? We are looking to, obviously, this model of catastrophic plate tectonics, where the continents are moving at rapid paces through the flood waters. And to explain it the best way I can, the pre-flood ocean crust, okay, it's dragged down into the mantle. And this is what I was saying earlier. This is subduction process, okay? So the prediction was by Dr. John Baumgartner that the ocean crust, okay, if this model has any truth or validity to it, should still be cold, since according to this model, okay, this only occurred thousands of years ago, this rapid plate movement, okay? Now, even though according to this model, even though this would have descended into the deep hot mantle, okay, it should still be cold if it only happened a few thousand years ago. And then seismic data from NASA, as I was pointing out earlier, they've actually they revealed these enormous slabs of cool rock, okay? But if you're thinking about down in the core, okay, it should actually be warm or melted. But this turned out to not be the case. And this was pretty phenomenal evidence and confirmation of flood geology, because it was a future testable prediction. And David, what are your thoughts on that too? And then we can also move on if you'd like, because I know Andrew doesn't have all night.
Oh yeah, I like
on
that.
geology for an hour. But I will say this. Andrew, David, whatever you want to say to that. And then Godzilla Freak, he probably has some input on this too. And like I said, I don't want to hog the mic. So go ahead. I yield.
Yeah, sure. So I am about to go to bed because I'm literally I am sorry. I was kind of falling asleep as you were talking, so I didn't quite catch everything you said. I It is almost 2 o'clock. Where I am.
That's hey, listen. We just had a solid 45 minutes of technical discussion on the heat problem and plate tectonics and predictions. So I appreciate that, and I always appreciate your willingness to dialogue and have these important discussions, especially on the details of these models, right, David? I think it's important to have more discussion on the technical aspects of these models, and the heat problem being one of them. Godzilla Freak, did you have some input before David had to get out of here?
Oh yeah, I just want to make a point on the mountains, where David made the point that, hey, the mountains are still rising, right? So it shouldn't be a problem. I'm just a bit tired here. And what I want to say regarding that is that it's not like the end of the process that's hard, right? Rather, it's like the start when the mountains first form. That's when it's really hard, when they're moving slowly. So you can respond to that if you like.
I'm not quite sure what you're saying.
Right, so like it's easy to have the slow plates continue to grow a mountain that's already there. But
Okay.
to form the mountain in the first place, that's what's more difficult.
Okay. So basically, are you arguing basically that the rate of the collision is too slow for it to have been able to uplift and form a mountain as when they first collided?
Yeah, something similar to that.
Okay, so what do you think is going to happen once those two plates end up colliding?
Well, I'm not sure what would happen, but I'm just saying it
Okay.
wouldn't explain the mountains forming exactly the way they do, as well as if they moved more quickly.
I mean, it explains things just fine. Um, okay.
Well, I
Yeah.
would have to read a bit more into that, but
Okay, so yeah.
what it seems
I-
like is that there's just not enough.
Yeah, so I'm just going to quote I'm going to quote right here from the Geological Society, UK. So basically, quote, 225 million years ago, India was an island situated off the Australian coast and separated by Asia from the ocean. The supercontinent Pangea began to break up 200 million years ago, and India started a northward drift up towards Asia 80 million years ago. And India was 6,400 kilometers south of the Asian continent, but moving towards it at a rate about 9 to 16 centimeters per year. So at this time, the ocean floor would have been subducting northward beneath Asia, and the plate margin would have been a convergent ocean continental one, just like the Andes today. So yeah, basically, the Eurasian plate was partially crumbled and buckled up above the Indian plate, but due to their low density and high buoyancy, neither continental plate could be subducted. This caused the continental crust to thicken due to folding and faulting by compressional forces pushing the Himalayas and the Tibetan plateau. The continental crust here is twice the average thickness at around 75 kilometers. The thickening of the continental crust marked by the end of the volcanic activity in the region, as any magma moving upwards would solidify it before it could reach the surface. And the Himalayas are still rising by more than 1 centimeter per year as India continues to move upward into Asia, which expands the occurrence of shallow focus earthquakes in the region today. However, the forces of weathering and erosion are lowering the Himalayas at about the same rate. The Himalayas and Tibetan plateau trends east-west and extends for 2,900 kilometers, reaching the maximum elevation of 8,848 meters. So, end quote.
Yeah,
So yeah,
like, again, I'm not saying that like you don't like come up with an explanation. I'm just questioning whether or not it's adequate to explain what we see, right? So maybe I'll just find out on my own. I'll try to look up if I can see some form of calculation for if there is enough force generated from the initial collision to cause what happens.
If I could respond to that real quick. So we're not denying the fact that the plates are moving right now at very slow paces, and the mountains are still rising at uniformitarian numbers, really, essentially, right? But it's the initial uplifting to get mountains that high is what we are saying, because we're looking at the current rate of movement. What did you say it was? It's about, I think overall on average, it's about 10 centimeters per year, the plates themselves, okay? So the point is, let's take Indian, Australian, and Eurasian plates, okay? Now, at only 10 centimeters per year, okay, at that movement, the collision of these two plates, okay, could not have been sufficient enough to push up the Himalayas. And to make it easy and understandable for everybody, that's like two cars colliding into each other, you know, traveling at 1-2 kilometers an hour. Okay, there's not going to be any buckling. There's not going to be any significant effect as compared to this meters per second movement or two cars traveling at each other at, say, 100 kilometers an hour. What would that result in? Well, it would result in rapid buckling of the rock strata that could have pushed up those mountains, okay, to where we see them today. Now we see today, okay, because catastrophic plate tectonics is a thing of the past, right? Now we see uniformitarian processes. Okay, yeah, so we still see the plates moving a bit. We still see the mountains rising a bit, obviously, because the plates are moving very slowly. Okay, but it's the initial catastrophic plate tectonics that can actually explain sufficiently the rapid buckling of the rock strata. Okay, uniformitarian processes, like you're saying, the 10 centimeters per year cannot explain the rapid buckling of the rock strata to push up those high mountains. But the most important point is the cold slabs prediction, that if this were the case through catastrophic plate tectonics, we should find these cold slabs, and we have found these cold slabs. And science, David, you would agree, is all about future testable prediction. Wouldn't you agree with that?
Yes, and of course falsification as well.
Right, exactly. So think about it. When that prediction was made by Dr. John Baumgartner, it didn't have to come back to be true, right? Maybe those cold slabs weren't discovered, and therefore rapid subduction, okay, would be not as valid as with the confirmed prediction is the point. And this was years before. Dr. John Baumgartner, I believe is a geophysicist, and he's done all this modeling. And the Bible itself says that the waters were all gathered together in one place, and therefore the land would be in one place. And catastrophic plate tectonics and the supercontinent was actually proposed by a creationist even before uniformitarian scientists hijacked the idea. This was proposed years ago. I think it was like in the 1800s. His name was Antonio
Pellegrini.
I've got it here somewhere. What was that? Oh, yeah. Was that you, Andrew?
Antonio Pellegrini or something like that.
Yeah. Antonio Snyder Pellegrini, I believe it was. Yeah, he published his theory. It was in French, though, and I don't know if it was ever translated it into English, but he proposed catastrophic plate tectonics and the supercontinent based on the Bible in Genesis talking about what seems to be a supercontinent, because it talks about the waters gathered together in one place. Therefore, you'd have all the land essentially in one place as well. Which is interesting. Yeah, I just Google history of plate tectonics, and you'll see Antonio Snyder pop up. Antonio Snyder in the 1800. Oh, actually, right here in his image, 1859. So, yeah. Go ahead. I know you're getting tired there, David.
Yeah, I'm definitely getting a little bit tired, and we could definitely pick up this topic for another day. If you could send me some information with those cold slabs, that'll be fantastic. I would love to read about it. But I'm literally falling asleep right now.
Hey, it's geology. It's
geology. I'll
transfer.
tell you, geology is my least favorite science. I literally fell asleep in geology class. I would much rather do biology and genetics than look at rocks.
Well, you are a biology major now, right?
Yes.
All right. Well, you know what? It's been exactly an hour. So we went an hour into geology and heat transfer, the so-called heat problem, testable predictions. Therefore, maybe this is a good way to segue into the next topic. And then we will open it up because I know there's a few people that are dying to get in. So, David, I know you're tired. It's late for you. You've got a debate to prep for next week and probably another 100 debates after that. So, did you have some final words?
Don't forget to come to the Neff debate next Friday night at 9 p.m. on Standing for Truth's channel. I think it'll be fun to do a standalone discussion just on the heat problem, like detailing where we can, but I was kind of planning on doing some calculations of my own and kind of calculating, okay, how much of this could theoretically happen and all of that. I think that'll be having more time to actually prepare for the actual calculation and the actual mathematics. That'll be a nice conversation to have.
All right. Well, I appreciate it, David. I appreciate your time. I'm glad we could have this talk on the Genesis flood, the heat problem, and testable predictions associated with CPT and so on. So next week's going to be fun. Battle of the Neffs, round 2, the sequel. So make sure you're here. We're going to have a lot of fun. Then an after show over on David Neff's channel. So thanks for doing it, Neff. An hour has flown by, and we can move into the next topic of the night. Maybe what we'll do, I saw you unmute yourself, Godzilla Free, so maybe you had something to say, but maybe if Rational Empiricist has a question, we can let Godzilla Free kick it off, since I kind of dominated that first hour and I want everybody to have speaking time. So go ahead, Godzilla Free. You can start, brother.
Well, no, I just had a question, and I was wondering if you would know the answer to it. Where I think part of the heat problem comes from the nuclear decay itself, right? The heat generated by the accelerated nuclear decay. Now, I've heard that with the Z-pinch method, right, the electrical currents that makes the heavier elements, after it's made, it rapidly goes down multiple layers, and then it slows down from there, right? I was just wondering how much heat is generated in that rapid process. And is it similar to if it just goes all the way through slowly? Because I don't know. I tried looking it up, but whenever I look up Z-pinch, it always talks about like potential power generation by like cold fusion, right? I haven't been able to find many results on it. So I was wondering if you knew the answer to that.
Yeah, that is from the Proton 21 laboratories. And that's under Walt Brown's model, where he talks about the higher elements all being created during that time, which essentially as a result would have, I believe it's called cold repacking, where it actually would have just kind of counterbalanced all the heat. Let me see what the exact name is, or the temperature. Cold repacking, I believe it is what they say takes the heat away. Now here's the thing. It's a very, very technical explanation. And even Walt Brown in his book in the beginning, which is massive, it's like an encyclopedia. When you get to that part on heat and the origin of all these radioactive elements, he actually directs you to an additional article that he wrote on another website to go look at for further information. So it's very technical. That's why we had heat transfer expert. What's his name? Bob Enyart and Brian Nickel. Well, they were on and they went into some technical explanations on that. So typically in discussion and debate, I don't really go down that route because it's very, I don't fully understand that specific explanation for it. So I usually go with like the CPT explanations with like hypercanes, supersonic steam jets, and it's all good to go with the cold repacking explanation. I think more study is definitely required for that. But yeah, that has to do with the Proton 21 laboratories and your exact question on the temperature, right? The numbers. To be honest with you, I don't know. That would be a question for Brian Nickel. But it's a very technical explanation. It's a good explanation, but I don't fully understand it, to be completely honest with you. I'm not sure anybody does.
It's like a really like high tech sort of study now that's just popping up more recently.
Yeah, I mean it's fascinating, and it has to do with Z-pinch, which they've observed these elements created in the Proton 21 laboratories. I think Jason was talking about it in the chat earlier. Let me see. Yeah, they created huge electricity bolts of lightning that resulted in the creation of these heavy elements. And therefore, during the catastrophic processes of the flood, right, the movements of the plates, the collision of the rocks would have had the same effect, where they would have created the same elements through these electrical reactions. And as a result, it's called cold repacking. It would have absorbed all the heat. That's the layman explanation of it. I mean, you'll have fun reading the article from Walt Brown on it, but it's a technical explanation. I mean, I typically in debates, I don't even know if I'd go down that route. For me, I debate so much. I like to go down the routes that I know that I fully understand. I can defend it. And that is probably the best explanation, but it's also the most technical explanation, which is why I think even when we have the PhDs on here, Dr. Lyle, Dr. Sarfati, Michael Ord, you don't really hear them go down that route either. I think there's also a lot of unknowns there too, but the cold repacking, if true, absorbs all the heat. Boom, no problem. So what are your thoughts on that, Godzilla Freak?
Yeah, I think maybe at this point, it's we don't quite know enough to really fully understand it. But at least hypothetically, it seems to be a solution. And maybe in the future, as we do more research into this, it'll be more clear as to what's really going on.
Yeah, like with the research being done with fusion and these electrical reactions and the Z-pinch, okay. There needs to be more on it, I think. And luckily, Walt Brown, in his book In the Beginning, the newest edition is coming out soon. George and I got a sneak peek at it, and there's a lot now on the heat problem because it's their number one argument that they're always bringing up, right? So Walt Brown and Brian Nickel, they're working on it. When Brian Nickel was on, he was talking about how he's working out the numbers, and he's going to be having a video on it soon. So I'm really excited to see more on it, other than just, I think there's a solid article on it. And when Brian Nickel and Bob Enyart were on the channel, we had them for almost 3 hours. That's probably the most technical video you'll find on the heat problem. But just like me and David, I mean, we just had this discussion for an hour, and the number of solutions that I put forth. I mean, we have the evidence in the rocks that accelerated nuclear decay happened. We know that happened, right? So now how do we get rid of the heat? Well, the easiest explanation is dump it into space. A lot of it could still be in the core. Okay, and there's a number of factors that could dump most of it into space. The Hypercane model, for example, supersonic steam jets. So I don't personally think you even have to go down the Z-pinch route, but if you want to, really go technical, yeah, that's a good explanation for it. But I'm not going to pretend that I understand all the details of it, right?
Yeah, I'm satisfied with that as an answer, because it might just be a bit too hard.
It's a fun one. It's a fun one, but man, yeah, it gets deep. So, anyways, yeah, why don't we open it up to a rational empiricist and open it up to more so an evolution talk now, universal common ancestry. And therefore, since this is kind of your specialty too, empiricist, you can get in on the fun.
Oh, sorry.
So, oh no, that's okay. That's okay. Since we're getting more into the evolution thing, and we'll keep it equally timed. You know, empiricists, take the floor. What are your thoughts on descent? Anything that you want to get out there, and then we'll just kind of have some back and forth friendly dialogue pertaining to your point. So go ahead.
Yeah, I kind of feel. Oh, am I upping it again?
Yeah, you just went full robot mode for a second. Oh yeah. Are we back to if we mute, then you go full robot mode?
Yeah, I don't know why it does that for some reason. Like even in like my streams with like speed of sound, for instance. So I don't know.
That's fine.
Like,
I'll just stay unmuted. No worries.
Okay.
That was funny though. At least we figured it out, right?
Yeah.
Critical thinking, that first debate we had.
Yeah, I kind of feel a bit I don't know, just because you guys were, like you said, you were talking about geology there, which isn't really my area of interest or expertise, if you want to call it that. So to bring it into common descent, I guess a question I might ask you standing just to get into it would be, I think in previous discussions, you and I have talked about nested hierarchies and how supposedly the creation model can explain this. And I want to hear your thoughts again on kind of the reason, because I hear you say that I believe something along the lines of the fact that we're created in God's image, therefore a nested hierarchy must exist. Could you explain that more, I guess is what I'm asking.
So the best way I can explain it, and quickly too, would be our model of design would start with Genesis and the fact that God creates man in his image, right? So obviously there's something about us that reflects the design or the divine. I apologize. So there's something about us that reflects the divine. So our model would suggest, okay, through predictions and retrodictions, we would expect to find a reflection, okay, in the design world, the way we create things, the way we design and engineer things. We should be able to get an idea or a sense, okay, through that as to maybe how God himself designed the biological world. Okay, so therefore, since we see humans and engineers building in essentially homologous patterns, nested hierarchical patterns, we even see what appears to be your transitional forms, right? You got the crossover SUVs that resist classification. I mean, that's the whole point. It's a crossover. It's a mix of a van and an SUV. You know, you got the best of both worlds. My parents just bought a new car from Chrysler. It's called the Gladiator. The thing is a beast. Google it. It's literally a mix. My dad pulled up. I said, what is that? It looks like a combination of a truck and a Jeep. That's exactly what it is. It's a combination of a truck and a Jeep. So therefore you have the best of both worlds, right? In terms of those vehicles, those modes of transportation. So our model would suggest that we can recognize design, okay, in the biological world based on how we're not divine, you know, we're not infinite. In our finite minds, we are building things that reflect the biological world. And God being infinite, we see that reflection, but he also has designed life with the ability to reproduce, to adapt, you know, so it's still so much more complex. That's why I typically say, hey, listen, we are in the infancy of understanding design. So yeah, in a nutshell, hey, we see nested hierarchical patterns in the design world, modes of transportation, computer code, computer programs, so on and so forth. We see the same thing in the biological world. Therefore, this is consistent with the design hypothesis, but it's also consistent with the descent hypothesis. I hope that made sense.
Yeah. So if I'm understanding you correctly, basically you would say, I don't want to misrepresent you, for instance, but like I believe you said something along the lines of how certain like what was it called again? Gladiator car, for instance.
Yeah.
How that kind of combines features from different groups. Is that kind of what you're saying?
Yeah, because you're looking at the truck design and you're looking at the Jeep design when it comes to the Gladiator. It's a newer vehicle. Google it. It's pretty cool. So you're looking at a combination of those types of vehicles into one. And we actually, and that's kind of what we see in the biological world when it comes to these mosaics, right? I mean, you got the platypus, which is a beautiful mosaic. You can look to Archaeopteryx. You can look to the mammal-like reptiles, the synapsids that we just had a show on the other day. You can look to Tiktaalik. You know, you see these mosaics in the biological world, and it's just so fascinating that humans are now recognizing that, hey, listen, that's a good design, right? So yeah, that would be my point.
Right. I guess my point there would be, if you were going to construct a hierarchy, for instance, I guess with the cars and trucks you mentioned, for instance, what would need to happen, for instance, within this, I guess, call it truck lineage, basically, you can have further modifications or elaborations on specific features. But for instance, you never see, or you should never see one feature in trucks, for instance, that we would call derived in phylogenetics being found in cars, for instance. And of course, we see that in cars and trucks, but we don't necessarily see that as clearly in living things. So, for instance, I would argue that transitional forms aren't mosaics per se. They're transitional in terms of their characters, but not in terms of their I guess in terms of like I said, it's kind of hard to kind of elaborate on the issue, but basically, I think we'd both agree that transitional forms in evolution at least are defined as creatures that show intermediate forms between ancestral and derived conditions, right?
Right. Yeah, I would. So here I've got it from some definitions and stuff from Berkeley. And so transitional fossil is any fossilized remains of a life form that exhibits traits common to both an ancestral group and, like you said, right, these derived traits. So it would be traits of the ancestral group and its derived descendant group. But my point would be that the term derived and also the descendant nature of the creature they're looking at, those are assumed, right? They're assuming the descent part. They're assuming that this feature, this trait, is actually derived from a previous, more basal structure, right? But that's
right.
not.
It's just like if we have kids. I mean, your children are going to have similar features that both parents have, and so why would you ever assume that if there was like a descendant that had the same structure, that this transitional form would be an ancestor necessarily, when it could just be a child? Right.
Right.
I mean, as far as I.
Yeah, and here, here's the thing. To throw it back to rational empiricist, what would you point to then? Because you're saying they're not necessarily mosaics, right? what would you point to in some of your most commonly cited so-called transitional forms like tectonic, Archaeopteryx, the mammal-like reptiles? What would you point to in terms of a trait that is, basal or derived, and not just like a fully functional characteristics or trait or structure? Like what would you point to? I've got a couple on the screen here.
Right. Well, first I would say that the term derived and ancestral, for instance, is relative, of course. So looking at what group you're studying, for instance, it depends on the in-group in comparison to the out-group, for instance, in phylogenetic terms. But I would say, for example, that if you're going to have a creature that is fossilized, then it would necessarily have to be complete in some sense. And of course, complete is another relative term, because in order for something to survive, of course, it has to be complete in some sense toward its environment.
Right.
So I would say, for instance, the common, and I don't know if you make this claim, but like the one common claim by other creationists would be what uses half a wing or half an eye, for instance.
Right.
But besides the points on irreducible complexity, which we could get into in a whole other discussion, but like I think that misses some of the points that it's not necessarily you have a wing-like structure and then you get one feather and then you get a second feather and then you get three feathers and then so on and so forth. I think it's still gradual, but it's a lot more complex than that. If that makes sense.
Yeah, that makes sense. What would it be like if you had a hammer, but take off let's just say you have like the handle part and take off the part that you actually pound things with. So let's say you have just this, so that if you just had the handle, that could still be used for something, some type of function, right?
Right.
Before it actually, and this is just a hypothetical, right? Obviously, before it actually evolved fully into the hammer, where now you're actually using it to pound a nail into something that you're building, right? So this halfway structure, according to the evolutionists, would still have a purpose and a function for that time until it has actually evolved into the, like, let's say, Archaeopteryx, until it's actually evolved into a structure that is now used and the purpose is for flying.
Right.
Does that kind of make sense? Is that kind of what you're saying?
Yeah, and I kind of dislike the term halfway because we would both agree that over generations populations are changing. So it's not really you have I mean, heck, even today's creatures aren't really complete or the end all be all stage in that sense. So
would it be like if I said that hammer, which is just the handle part and not the main part that is supposed to be used for a hammer, if I were to say, well, that's halfway hammer, essentially that would be incorrect because it would just be whatever it is at that time, right? Whatever it's used for, whatever, it's not halfway. I mean, is that kind of what you're saying?
I think that's vaguely what I'm saying. Yeah, I think that's a good analogy.
Okay. And here's the thing is when it comes to the design model, we are looking to function and purpose. And that's why we would say that, like, right here is an amphibious assault vehicle, which is a mix of a vehicle built for the ocean and built for land, right? It's built for that transitional environment between ocean and land. And the features of the vehicle and the design is there for a purpose, for a reason. It was designed that way. And therefore, when we look to the so-called transitionals, and we would say that they are more so mosaic, because whatever feature you're looking at it is there for a purpose. It would be there for a design. And we could look to tectonic. We could look to the synapsids. We could look to, I believe in the same way that we could look to a platypus. The way that it's designed, the traits that it has, the features that it has, they're there for a purpose. They're functional, pertaining to the respective environment of the creature, right? Especially with epigenetics now, right? And convergent evolution, a lot of creatures, because they have those built-in mechanisms to adapt depending on the environmental condition, they can oftentimes adapt the same appearance and the same traits, even though even according to the evolutionists, they are so distantly related, that the features you're looking at are not even homologous. They would say they're analogous. My point is that there's just a lot of aspects and factors. So yeah, according to our model, as long as we see these so-called transitionals, the features that we're looking at, that we're analyzing, if they're there for a purpose, if they're there for a function, that's exactly what we would expect, in the same way that, it's the same way humans design transitional like forms. Go ahead, empiricist.
Right. I would agree with that broadly, like of course, for instance, the color of blood, for instance, doesn't necessarily have a purpose, at least in a physical sense. So in that sense, not all features are for some kind of purpose, but that's kind of besides the point. I guess I would agree that most features, other than those kinds of blood ones, are basically built for that kind of purpose. I think what we would disagree with is the fact that over these supposed long ages, the purpose itself has changed. For instance,
Right.
So, like for instance, I believe it's actually, maybe it was more recent, but it was previously assumed that the lungs, at least in the evolution model, evolved from some kind of swim bladder in fish, where now it's actually, I think, more widely accepted. I'm not completely certain, but more widely accepted that actually lungs came first, and then some kind of structure similar to lungs or some kind of precursor structure then diverged and became the swim bladder in those kinds of fishes, basically, I think. So examples like that, or the digits of the forelimbs, for instance, from fins, I think that's where we would disagree in terms of the purpose itself has changed over time.
Right.
Do you
And
mind if
that
I
would be,
jump in real quick?
yeah, I'm going to make this one last point, and then I'm going to yield to
Yeah,
some
go
other people, is that just like the homologous structures, and correct me if I'm wrong, you have the similar structures, but in the creatures where we're looking at the homology, okay, let's say it's the forelimb, okay, whatever structure we're looking at. In one, it has been derived in a way that's suitable for that creature in that environment. So even though it's a similar structure, it's still different because it has evolved differently for that creature. But it's still been derived ultimately from past common ancestors according to the evolutionary model. Every trait, every characteristic, every structure has essentially been derived from previous common ancestors. That's the whole point of the law of monophyly, right? That we can never outgrow our ancestry. A eukaryote will never stop being a eukaryote. A mammal will never stop being a mammal. We are always what our ancestors were. We only add traits. We only add characteristics, right?
Right. Yeah. I would say, for instance, and I feel like you're probably going to disagree with me on this, but I would say that function in biology, at least, does not correlate with form. Like it does in certain circumstances, but it's not a universal rule. Like if I may provide an example, you can have different forms for similar functions. For instance, like you often see these analogous structures in living things. So like wings is a common example in different organisms. But you also see the same form for different functions. For instance, like you can see different modifications of, I believe one example would be spider silk, for instance. Like spiders don't just use silk to trap insects in webs, for instance. They can use them to kind of throw them over them like a little net, basically, which is pretty cool. But so something along those lines. I don't feel that form necessarily follows with function.
Well, I think that the things we design also can do that, right? We have different things we make that can serve multiple different functions. Like even a man-made net could be used for a trap or to catch something actively, right?
Right.
So I don't
Right. I was gonna
see
say-
why that's too different or unexpected.
Well, just like
So
a
earlier we
shoe.
were talking about how. Sorry, guys.
Actually, Pigs, I just want to make this point because when it comes
go ahead.
to, like, for example, you have a variety of designs in terms of, let's say, shoes, which is served to put on your foot to walk around with, and yet you've got CrossFit shoes, running shoes, wrestling shoes, golfing shoes, all different type, walking shoes, all different types of functional purposes for really the same underlying design, in the same way that you can buy a Volkswagen Jetta or a Chevy Cruze in a regular engine, and you can also buy it with a diesel, so you've got these different designs in the design world for the same underlying structure. You could say, let's say the engine or a shoe or even a hat. That we also see that in the biological world. I mean, you could see that with mammals. You could see that with placental mammals or marsupials, for example, too, right? Or even in the ocean, you can see you've got whales, which are mammals, right? They're an ocean creature. But then you've also got a shark, which is classified as a fish. Why are they so different? The evolutionists would say, why didn't God just build everything, design everything that's in the ocean the same? But it's different purposes. It's different functional requirements depending on the environment. A lot of it comes down to ecosystem balance. So it's a variety of designs coming from the same mind, because I'm one mind, and I can write books, I can build things, I can do a number of things, all coming from one mind. Well, why do they design cars in say Great Britain, where the steering wheel is on the opposite side as in North America? It's just reflection, I think, of design, once again, that we see in the biological world, and it's always there necessarily for function, for purpose, and I'll yield there. That's the last thing I'll say, and I'm going to we're going to let Rational Empiricist respond, and then Pigs Can Fly. We'll let you take over from there, and I'll put the link. Oh, I got Danny here. Danny, my good man. Danny, my good. Listen, Danny, you're here. You're Mr. Philosophy. But for now, we're going to keep it to this topic until we've exhausted it. Then we'll go down your philosophical rabbit hole.
Wait, 1 second. I'm not okay. Am I known for this? Am I known for derailing conversations?
Oh yeah.
Okay.
No, I wouldn't say derail.
I don't think I am. Right. I remain silent until my ears. I'm my foxhole. I'm waiting. Right. I'm a crocodile in the water here. Okay.
No, Dan. I gotta say, Danny keeps it fun, and what I like about Danny is he can help keep an after show going to record lengths. I mean, my after show from I think a week ago was like almost 8 hours, 6 to 8 hours, because he knows how to hold a conversation, Danny. So I respect that. We respect that. So I put the link in the chat. Whoever wants to join and bring their thoughts pertaining to this topic. Once we've exhausted this topic, who knows where the night will take us. So go ahead, Rational Empiricist, the floor is yours, and then we're going to hand it over to Pigs Can Fly, and then probably a free-for-all after that. So go ahead.
Yeah, I feel like after we've exhausted this topic, probably I will have to head out just like David, because it is getting late for me as well. But I want to say real quick, let's see. So my point, I guess, would be in the genetics, which, of course, we know the potential mechanisms, at least, for how genes are inherited from one generation to the next. Like, we can build pedigrees on this, for instance. However, we cannot necessarily do the same thing in terms of creation, for instance. Like, we don't have the same kind of mechanism, basically. Oh, someone left.
You just Godzilla for it.
Yeah. So I guess I'll leave it at that for now. And Pigs, did you want to respond to that?
Well, I had a thought. I almost forgot it actually, but I'll go back and retrace my thoughts. So I think that remember you talked about how lungs possibly developed first, but I think the biggest problem with this entire notion of how evolution, has taken place, is that for that to even really happen, so imagine that you have the first animal that's ever developed lungs. This animal has to somehow find a mate that will carry on that genetic information, and then of course impose that into the next generation. And then even from there, you have to assume that it's somehow going to survive the next generation onward, right? So it's supposed to take several generations just to even become a fully functional gene within the genome. That's assuming that this even works the way it's been espoused. So that to me is one really big issue there. And I mean, again, the way you described it, you said that this was going to be something that happened within fish. These are already existing fish. That means that they never needed lungs to begin with. So I'm just kind of curious, like, why would they ever need to develop lungs if they didn't have to have that to survive in the first place?
My guess would probably be the fact that back then maybe the oxygen levels were lower in the kinds of environments they were living in. That's my guess. I would really have to look into it because I generally don't know. So sorry about that.
I would only drive the natural selection, not the order of mutation.
Oh, say that again, Argaffa?
It would only drive the natural selection. It wouldn't affect the random mutation.
Right. That is correct.
So how many generations would it take to convert a swim bladder into a lung? Based off of the known mutation rate, we assume.
Probably at least a few dozen. It depends on what gene you're looking at, essentially. If you're looking at a regulatory gene, for instance. Oh, Emery's here.
Wow, Emery, I thought you were going to sleep, man.
No, I wasn't going to sleep. I had work I needed to get done.
And that's why you're on here chatting?
Well, no. The reason I'm on here chatting is because I currently have an alignment of 150,000 nucleotide bases per organism running in the background, and I literally can't do anything else. So,
well, Emery, don't worry. We're gonna help to keep you up all night. You're pulling an all-nighter like most of us typically do.
Well, and I'm already working on an all-nighter standing because I'm a couple hours ahead of you. Don't forget that. So,
are you? It's 2:35 in the morning for me. What time? Is it
for some reason, I keep thinking you're in Western Canada. I don't know why, but it is 2:30 in the morning for me. So
yes. It's most people are behind us on time. I don't want to derail the conversation, but I do want to welcome our new guests. We've got Jungle Jargon. We've got Jamie. We've got Danny, who I introduced earlier. We got our Gotha. Emery, I want to say one of these days maybe you, me, and Raw Matt, we can get together for a stream, and you can show us some of those statistical baraminology. We're really interested in that. And real quick before you respond to that, we've got LPP, the man, the myth, the legend himself. So here we go. Party begins.
I don't know why I keep getting all these ego boosts. I'm already arrogant enough, is what I'm told.
Hey, LPP, how dare you call me out earlier on my chapstick? It's cold over here in Canada.
Okay,
It's cold everywhere.
Bro, so I clicked into the stream and you were putting on lip balm or whatever, and I'm like, man, I cannot let this go. This is too good.
Especially because it's my wife, so it's purple. I know. I'm sorry.
Nice.
I've devolved, like my shirt says.
Nice.
Oh,
Okay,
we've got.
So part of the reason I was hopping in real quick is so Andrew, do you think that lungs were devised from one gene?
My guess would probably be no.
Okay, so I mean, obviously the answer is no. And there's multiple different proteins and regulatory elements that are required for its production. And that's just what we've discovered so far. We're just finding more and more things. So if we know beyond doubt that there are a plethora of different functional sequences that are required to work in conjunction, both separately and in conjunction, how do you think it's plausible that you don't have to have all of them simultaneously when everything that we observe necessitates them working in conjunction and interdependently?
Right. Well, I guess I would disagree with the premise that they would have to arise in this circumstance.
Well, if they weren't useful in the individual stages along the pathway to get to a fully functional lung, they would get selected out because they're wasteful.
Right. Right.
So
oh, go ahead.
I mean, I think you understand that's what we're saying. That's what LPP is saying. It has to be functional along the entire way and useful, or it gets selected out.
Oh,
Right.
It's not even just the selected out part. It's like you die. I mean, obviously the selected out portion comes from death, but the point I'm making is I'm asking you, Andrew, not a hypothetical, right? We're talking about a known real world reality. I mean, we get all sorts of genetic diseases where you have a point mutation in just one of the sequences that's necessary for XYZ function, right? And those point mutations cause cascade collapse of all of the different components that need to work in unison. So if we observe this in real time as being the end outcome, if you don't have these things in the first place, like, how do you actually think it's plausible? Again, how do you think it's plausible? Not hypothetical numbers. Oh, well, if all these things all happen to happen in the appropriate order perfectly, we could somehow result in this. I'm talking about in the real world. Because I feel like when I listen to you talk a lot, it's like you operate in this like hypothetical bubble that's separated from reality.
Okay, so the question is how I guess how these genes evolved. I don't quite understand the question, because I feel that, for instance, the main mechanism for the kind of change we're talking about morphologically is not necessarily, because if you're talking about developmental genes, for instance, genes that control the major body plans, I would agree that changing an amino acid of that transcription factor is likely going to cause more damage than it's going to create. And I think that's why most changes being discovered so far are not necessarily in the developmental genes themselves, because it can be hard to I guess differentiate between the two.
Do you understand that what we're talking about is not like a protein change? We're talking about something. We're talking about an entirely different cell type.
Right.
Well,
oh, go ahead.
I was gonna say, Andrew, have you heard of the Richard Lenski experiment on E. coli?
Yes, it's not my most looked into example.
Okay. I just wanted to see if you had information on it, because I had to, well, more or less, I had a debate with a PhD biologist by the name of Dr. Ling about that particular experiment. She posted it as the best evolutionary evidence to date. And so I went and did the research, looked into the documents that she gave me, and then I looked into further documents regarding the experiment later dated. And it turns out, so from the initial onset, what they did is they took E. coli, they put it in a culture genome. I guess it's supposed to read the genome within this like spinning device. And they had went through about 30,000 different generations before they got a functional change in the genome. Now, what they thought was a functional change was actually already pre-existing information in the genome after the fact that they didn't realize was there from the beginning. It was in the intergenic regions, and it had been, it actually had been placed within a broken gene. It basically lost the ability for it to use its flagellum, and that gene that was intergenic was placed in the broken genetic area there. So that's what allowed it to apparently digest citrate, and then that's essentially how the change was effectively made there. Now, again, they didn't find that out until later, so they assumed that this was just evidence that there can be, hard changes through mutations like that. And even Richard Lenski had to recant on that notion after going back through the genomic information that was gathered from the initial genotype.
Was it E. coli that had the ability to digest nylon before nylon was invented?
I don't believe so. I think it's a different bacteria.
No, that's a different bacteria.
Nylonase. It was nylonase. But here's the thing with nylon. It's made from oil. So the actual bacteria digested oil. So therefore, it could also digest nylon and other polyurethane things.
Right.
No change.
The reason why I'm bringing that up, though, Andrew, just that even that Dr. Ling had to go back and say, okay, well, I apologize. I didn't see this other new document, and I'm wrong, basically. So I wasn't sure if you had known that or had gone over any of that information. But even like PhD biologists aren't looking at all the data. They're just looking at what they might already have seen beforehand, and they're not always getting up to date on their information for some of this stuff.
Right. Of course. Yeah.
So, quick question for you, Andrew. So, you talked about like regulatory factors and different things, regulatory genes and such. What is your knowledge on like how cell types are specified?
Like in terms of embryonic development?
Yeah, but I mean, like, what is the actual functions and actions that result in the cell type being specified, going from stem cell to a specific cell type? Like, do you know how that actually is happening? Like, what's being delineated inside the cell?
Right. Well, isn't it specific factors within the I guess the cells in a sense are communicating with each other using these.
No. Inside the cell itself, do you know what the action is?
Oh,
that is
inside
resulting, that's causing the cell type specificity.
Right. Or you're talking about the proteins binding to the DNA elements, right?
Well, I mean, there is protein binding, but I mean, like, do you like? I'm asking you, like, please delineate your knowledge on how that's actually occurring. Like, what is being done, and is it protein dependent? Is it based on just genes? Like, how is the cell type actually being specified?
Right. Well, I guess my knowledge on it is that you have these transcription factors that basically, along with, I guess there are many involved, but they bind to specific DNA sites, and that helps to promote, or I guess silence in a sense, the transcription of those genes, basically under cis-regulatory changes, I believe.
Well, I mean, the transcription factors, that's like the next stage. That's the expression level of, I'm talking about like what is being executed in order for the transcription factors to have different actions than they would in a different cell type.
Are you asking what causes a cell to be a blood cell versus a neuron?
Yes, but I'm asking specifically in the context of what is necessary prior to transcription and expression of genes that vary based on cell type. What causes that?
Well, I guess I would say other genes that are nearby. I mean, like you have this cascade of effects. I don't quite understand the question.
Okay, so, and this is why I've called you out on this before, of you are clearly researching and diving into the very, very high level hypotheticals from the evolutionary biology perspective and not actually the real world practical application. So we know, and there's lectures on this, I think I've actually mentioned this to you before, and I've talked about it in many streams I think you've been in, that we now know beyond all doubt that cell types, one of the absolute number one primary reasons for cell type specificity, comes directly from acetylation and methylation and other epigenetic tagging that has absolutely zero to do with genes by themselves. It both influences the histone structure based on the chromosomes based on cell type. It varies the expression and the silencing and the amplification of different genes, and it also modifies which open reading frame of the exact same freaking sequence is expressed in cell type A versus cell type B. So we're now looking at hyperspecific variation control in a controlled manner of functions based on cell type that has absolutely zero to do with the genes by themselves. And all of those functions are expressed and executed via proteins that have various like cell type specific sequences in order to execute those things I was talking about. Like, we know this beyond doubt.
Right.
And they've actually developed new technology within the last 5 years just to be able to read this stuff. And now they're discovering, like, holy crap, they've gotten all the way to the point of, like, this sequence is expressed X number of different ways in these different cell types. And then when you think things I've talked about before in relation to, like, content delivery networks, we have all of these, like, clusters of protein coding genes in the genome. And for years, we've heard ad nauseum from evolutionary biologists that this stuff hasn't, all the stuff in between has no bearing and whatnot. What are we now discovering? Oh, wait, it's regulatory components. Oh, wait, the reason that this has a little cluster over here is that in cell type A, this little cluster is the one that's being expressed because it doesn't need all this stuff that's in cluster B. So I don't understand how if we know this to be true, we know we have to have all these different components that must work in unison. And when I say multiple components, I mean, we're talking about literally thousands of enzymes and different proteins that are functional based on cell type. Like, I don't understand how this goes back to my original point of if you have to have all these things that work in congruence in order to reach the end result objective, what we see in different organs and whatnot. Like, I don't understand how you find that remotely plausible that thousands of things that work together all just somehow happen to happen, and they got clustered in the same like a little bubble in the genome. Oh, and they have thousands of different cell type specific enzymes. Like, how do you explain that from an environmental pressure standpoint?
From like natural selection, I don't think natural selection causes those kinds of changes to begin with.
I didn't say. Did I say the words natural selection? I'm pretty sure I said the words environmental pressures. So how did you get natural selection of environmental pressures?
Okay, sorry, I must have misunderstood.
I mean,
I don't understand the difference.
It is your perspective that all these things are a result of environmental pressures, right?
I guess to make sure we're on the same terms, what do you mean by environmental pressures? I guess.
Oh, good Lord, bro! You use that.
Well, I mean, LPP. You just said.
What do you think are the root cause of the new functions?
Mutations.
As a result of
solar radiation.
Errors in replication, I guess.
Okay, that are caused by environmental pressures, right?
Oh.
Well, not always.
No.
LPP, can I hop in here a second? I see what you're driving at, but mutations are not caused by environmental pressures in most cases. Most cases, it's just a replication error.
Right.
The issue that I think where you're trying to go is which mutations remain and aren't filtered out. That
Correct.
would be the result of environmental pressures,
which is
not
why
the ones that just happen.
Which is why I said new functions. Like, what is the result of the new functions? Is the whole point I'm making here, and the point I'm making, the ultimate point I'm making, is that, I mean, you mentioned transcription factors. Okay, in eukaryotes, how many known proteins are there required for baseline transcription?
I don't know the number off the top of my head.
Okay, there's 85.
85. Okay.
Many of them only do protein-protein interaction. They do not do protein-DNA interaction. They leave before transcription actually is initiated. Like, many of them are released well before transcription ever even starts. Right. So I don't. Again, this goes back to plausibility. So you've got 85 proteins, right? They work. The vast majority of them are gone before transcription is ever initiated. Like, they've come in, done their little thing, moved the process forward just a smidge. They leave. New ones come in. Next step, get a little bit closer, and then get everything all lined up, organized, clamped, prepared, activated, and then there's one final piece that this last one comes in. Boom! Now we've got transcription, but all these other ones are already gone. So how is it plausible that all these ones that are not around for the end action were somehow created through undirected replication errors and then environmental pressures and natural selection to somehow result in all of the functional components that are necessary for transcription to occur?
Well, I guess that would be a topic for the origin of eukaryotic transcription. I don't think that's kind of the camp I would say where most changes occur. I don't think the changes themselves are in any of the proteins that influence regulation. I think it's the changes in the DNA sequence where the proteins bind to be specific.
Have you ever written an essay, like a 1,000-word essay?
Well, yeah.
You think that if you wrote a 1,000-word essay and then you wrote some sort of program that would randomly replace letters in your essay with other letters, how long do you think that it would take before it would completely rewrite that 1,000 word essay to be something that spoke about a totally different topic and made sense?
Probably a long time, but I don't necessarily think that's applicable to DNA.
Well, see, that's the thing is, like, I don't think you understand how complex a single protein is. They range from between 200 amino acids, which is, there are 20 amino acids that are used in life. That is a little less complex than the English alphabet, all right? So I'll grant you that, but it ranges from 200 is at the smallest known protein to 33,000, which is the longest protein, which is Titan. Ribosomes, which are essential, are 14,000 amino acids in length.
Yes.
If I remember correctly, ATP synthase, which is required for metabolism at all, is 7,000. So I'm asking about 1,000 word essay. I think that's fair and on the low end.
Right.
You have to randomly change these. You have to randomly change these letters.
Right, like the genes themselves are what changing. Is that what you're asking?
Yeah, the genes have to change.
I think
Randomly.
that's where I would disagree.
You don't think that the genes have to change?
Not always. I don't think that that's the main source of morphological change or variation over time.
Why not?
There's something wrong with that logic.
What do you think is?
Okay, at this point, guys,
main
why do we
source?
waste time in these conversations if that's going to be denied when, like,
Well, he's 17.
he's 17, but he argues extraordinarily strongly about this stuff, has a decent amount of knowledge, and now he's going to deny that. I mean, dude, what do you think of de novo gene is?
A gene that's basically created from scratch would be my guess, from a sequence that doesn't have a function beforehand.
Okay. So
Andrew,
the
Sorry.
1,000-word paragraph or the 1,000-word essay, you're from your position of what you just said is 1,000-word essay transforms into completely different 1,000-word essay. Like, I'm not really, I don't understand how that does not compute.
In one job.
Right. Well, that's not what I'm saying, though. I'm saying the application of that essay, for instance, or the gene itself is what's changing. Like, we know if you take different genes and use them in different amounts or in different timing, you get very different results.
I'm talking about a protein.
Right, but I'm not talking about protein. I think is the miscommunication.
Okay, so if you want to claim,
Well, that would make it even.
You go, Matt.
Sorry, I was just saying that would just make it even more unlikely, to be honest. So it seems to me like we're missing the whole concept here. Like, if you're looking at the chromosome of, like, say, just the Y chromosome of a human being, right? They have a crazy number of genes that are within just the one chromosome, right? And we have 23. So the whole point we're making there is that you're saying for one of those functional genes to change, it doesn't have to be like a mutation. That kind of confused me whenever you said that.
Well, I do think it's mutations. I don't think it's mutations in the coding regions themselves. Because
I mean, I agree. It can be in the intergenic regions. I'm not saying anything against that. However, most often the case is that in the intergenic regions, these are non-functional genes. In other words, they're more like they're on like an off switch position, where they're instated in a place where they cannot be functional at the time. But the only real reason they would have any reason to change that is if it's being passed on to another generation that is going to allow that to become a functional gene. That's the whole point.
Dude,
They have to be pre-existing.
You have to have protein coding genes change at some point. Abiogenesis did not start with chitin. It didn't start with ribosomes. It didn't start with ATP synthase.
Right. Well, we're not talking about abiogenesis at this point. We're talking about how new functions came about. Presumably, I guess, unless I've been misunderstanding what you guys have been asking.
No, I understand.
Let me hop in here.
Okay.
Okay, empiricists, we've gone back and forth on this before, but I think you guys are talking about the same thing, but you're kind of going to different places. Like, basically, what Argatha wasn't trying to go to abiogenesis here. He was trying to say is, in the last universal common ancestor didn't have all the proteins that we see in the various disparate organisms that are descended from it in the evolutionary mindset. So at some point we have to get new protein genes. Am I representing you correctly, Agatha?
Yep, you got it.
Okay. So and that's what his argument is. Now I understand what you're arguing too, because I've actually done quite a bit of research on this. You're essentially arguing that in the quote unquote junk DNA, for lack of a better word, which is non-coding, you can have basically free reign to mutate as much as you want, and eventually you might mutate yourself into a new function. Is that essentially what your argument is?
Right. Yeah. I guess to be specific, I'm arguing that the changes are occurring, like in enhancers, for instance, enhancer regions.
Okay.
The cis regulatory elements next to the gene in question that control the expression of that gene, but don't change the gene itself.
So your argument essentially is that the protein coding genes themselves are not being changed. What's going on is that their regulatory factors are being changed, which is causing them to produce different things. Am I correct on that?
Right. Yeah. I think that's at least a big fraction of the changes going on. I don't think it's all of the changes necessarily. I just think it's a lot of the relevant ones.
Okay. That's something I honestly that's an argument that is not one I'm quite as familiar with. But I will say, like, if you're going to edit the regulatory genes, like a lot of okay, let me step back just a second. A lot of protein coding genes are regulated by multiple genes. Like I think that the genes for hair color, it's like 11 different genes or something like that. So there's a lot. So in other words, if you're going to make a change, you're going to have to get, generally speaking, multiple mutations in multiple places at the same time to get that particular change to be made. And then you've got the problem of selection actually being able to see that. Because if you make, I don't know, you make a new protein. Okay, you made a new protein. Let's just grant you that. The problem is selection can't see into the genome to select for a protein, or into the proteome rather, to select for a protein, or into a genome to select for a gene. It only works on whole organisms, and it only acts on things that provide reproductive benefit. So if this new protein helps an organism, be able to see better, but the organism is unlucky and is born sterile, it's not going to do anything. And it just goes away, and then you have to get it again. And then you've got the other problem, which is genetic drift. And genetic drift, I don't know how much you know about it, but I'll simplify it for the audience. It's essentially probabilities applied to populations. So if you have a gene that is, one copy of the gene is at 70% frequency and the other one's at 30% frequency, there's a 70% chance that the one at the higher frequency will what's called drift to fixation. So in other words, it will just become the only thing in the population. There's a 70% chance that will happen. And if you're just getting something new, like with one new regulatory change, your chances of drifting out of the population are really, really, really high. So the idea of getting de novo genes or de novo regulatory elements, you're fighting a very, very uphill battle just to do it once. And it has to happen countless times across the evolutionary paradigm. And that's why I can't get behind that, because it's fantastically improbable. And I mean, to the point where mathematically it would be impossible. I think if you actually did the math on it, I'm terrible at math, so I haven't done it. But if you actually work the math, it doesn't work in the way that it needs to in order to get where you're going. And I'll shut up now so you can say something if you want.
Yeah, I think our Gaffa want to say something real quick.
Oh, sure, go ahead.
Oh, I was just going to add that the probability of ATP synthase forming randomly is several times more than the number of atoms in the universe interacting as supercomputers processing a possible protein combination that would get ATP synthase every Planck second since the beginning of the universe. The probability is not just like really, really big. It's you can't fathom the number big or small, I guess. The probability is really, really small. It's well beyond 1 to the 82nd power. I think 1 to the 50 is the point at which a mathematician would say this is impossible for it to occur on Earth. And then I don't know what they would say for the entire universe. I think it's 1 to the 150th power, but the smallest protein, like just a 200 amino acid protein, has a probability of 200 times 1.3 is.
I'm glad I hear a calculator, because otherwise I would think you
260. No, I'm doing it in my head. So 260. So it's 10 to the 260th power. So 1 divided by 10 to the 260th power, which is way beyond the point at which a mathematician would say this can't happen in the universe. It's impossible.
Like an impossibility. I think it's like 1 times 10 to the 65th or something like that. Beyond that would be an impossibility, mathematically speaking.
Yeah, I'd have to look into those kinds of probabilities.
Well, just look up how many amino acids are in ATP synthase. Note the fact that there are 20 amino acids used in life. Will grant you that the other 100-something other amino acids that could possibly exist aren't a problem. We can just ignore them and just go with the 20. That gives you 7,000. 200. 20 to the power of 7,000. 7,000 times 1.3 to convert it into base 10 is, or power of 10, is more. It's like bigger. What is 7,000? Okay, I need a calculator for that one.
Bob, you're funny.
9,100. So write a 0, a dot, and then 9,100 zeros in a row, and then a 1. That is the probability of ATP synthase ever occurring. And that is assuming we ignore the other amino acid possible orientations. And that's also ignoring homochirality.
Let's put it this way.
And that's only the amino acids.
Anything...
That's not even including the codons that have to code for that thing at the same time. Because you got to have both.
Right. If you've probably heard of James Tour, right, Andrew?
Yeah, I've heard of him. Haven't looked into any of his videos.
Okay, so he was talking about just possible interactions between the 6 proteins, the D-pyranose proteins. He said that the possible interactions for just these 6, and there's supposed to be like many more. I think it's like 47 or something like that. So just the 6, right, is 1 times 10 to the 79 billionth interactions that are possible. Okay. And again, this is just the 6. There are only 1 times 10 to the 90 particles in the known universe. That's including all stars, dust, everything you can think of, right? All together. So it's an insanely large number to even fathom. And that's just for interactions. That has nothing to do with like the actual functionality or anything like that. Just to put it in perspective, this is like a grand scale we can't even come close to understanding, okay?
Right. Well, I guess I just leave it at the point, because I do have to take off soon. I don't know how long you'd want me to continue this kind of conversation. I don't want to keep up the spotlight here for too long. But I would just say that a problem is that a problem like that is really just something you haven't quite solved yet. I think is what I would say, that just because, yeah, I'll just leave it at that. But unless anyone had any further like comments or questions or something they want to ask me, then I gotta head out now, unfortunately.
Have a good night, man.
All right. See you guys, and
Not a
thanks
problem.
for having
Hey,
me
have
on.
a pleasant night.
Oh, I was muted.
Oh, did you want to say something, Argo?
Oh, I was gonna. But okay, I'll just say it. So, no, I forgot it. Never mind. Good night, man.
All right. See you guys.
Hey, have a blessed night. Take care.
I'll do a
Danny,
face
you
lap.
still there? You sleeping?
Face lap time.
I'm still trying to remember what I was actually gonna say to him.
I think the really important thing to gather from that whole conversation was whenever you know,
I
John
literally
Maxwell
made my
was
point,
talking about.
realized I was muted, unmuted, and then forgot my point.
All right. No, I don't feel so bad.
There's that too.
No, Pigs, go ahead and back and say what you were getting into.
I was just gonna make a joke. It's not a problem.
Oh.
It's not a big deal.
And I guess my takeaway from somebody like Rational, and I guess I'll lump Danny into this too, although he's not the science nerd, he's the philosophy nerd. But you know, it's possible to have a good conversation with people you disagree with even today, which is a big plus. But I'm not sure. Like, I think a lot of people, and Danny, don't take offense to this, but I think a lot of people, you can throw evidence at them until you're blue in the face, and it just doesn't matter because they don't want to see the evidence, and it's a very unfortunate. But it's humans as people don't like to change, and we don't like to be wrong, and so if they can find a wiggle room out of the evidence, they will.
I think Danny leans in that direction.
The truth has to change our hearts. The spirit of truth has to work in our hearts to convince us to do what's right, or to believe what's right too, or what's true.
Oh, unsolved answers. Oh yeah, okay. I remember what I was gonna say now. So he was saying that like we just haven't solved it yet, kind of thing, right? Like maybe there's a law or something, but that doesn't work if the current model is random mutation, natural selecting acting upon those random mutations to find or to select out the ones that are bad and preserve the ones that are good. that does not negate the probability of trying to find any of these proteins.
Correct. I was actually going to say that it actually that's just another step in the process. Then, if you think about it, or at least it would. So, assuming that this law, if it did exist, were to actually take effect here, it would maybe cut down the probability by half. So, yeah, that really doesn't help your case at all in the end.
I mean, we're really not talking about something far beyond the idea of asking, do you think that it's possible? Do you think that it's probable or plausible to conclude that the Bible, the entire Bible, was written by somebody randomly writing letters? Because that's the mechanism that evolution proposes to come up with life.
I like John Maddox's perspective on that, where he talks about the, it's like if you were to expect an entire coded software program to change from one program to an entirely different one, that's basically the kind of thing we're talking about here. Like, how long would it take for a random, sequencing processor to do that and have a fully functional, automated program that designed?
I'll tell you, it'll never happen. It'll never happen.
Exactly.
You want to take something. You want to take something. What's a small game like Super Mario Brothers, and you want to randomly change the bit in the code. And this is just binary. It's not even quaternary. So you want to, or binary if you want to go that way. To change the code from Super Mario Brothers to, I don't know, Super Mario Brothers 2 or The Legend of Zelda.
Either way, I wouldn't expect to have any Easter eggs.
It will break. Far.
I ain't playing anything got no Easter eggs, okay?
What about Easter eggs?
I said either way, it's not going to have any Easter eggs, and I'm not playing it if it don't have any of those.
You played Breath of the Wild?
Yeah, I love that game. It was pretty fun.
Oh yeah.
You can fly yourself. You can fly yourself across the map.
Oh yeah.
You can freeze lock the tree, and then you can jump onto the tree. If you guys haven't tried that, it's hilarious.
They found out they could use magnesis to lift one of those cart things that go on the rails, line carts.
Yeah.
You can lift, you can set another one on top of it, and then lift the one below it, and lift yourself up into the sky, and then jump off and fly across the whole map.
Yeah, I watched people do the like a speed run where they beat the entire game within 30 minutes, and it's so crazy to watch. They actually have a spoof version of that. There's a channel I watched called Terminal Montage, and his stuff is hilarious because he makes fun of all kinds of video games. And I think his funniest take is the one on Kirby, because he has Kirby as a Christian. He's the only Christian of all the game characters. And if you haven't seen that stuff, it's pretty funny. You should check it out.
Link it.
I
might check it out.
I mean, hang on a second here. I'll try to pull up one of the videos.
All right. But yeah, I watched some speed runs of Breath of the Wild. It was, I found it impressive. The way that they fought Ganon, and the way that they got the paraglider and then immediately jumped off of the island and then just landed right on top of a horse. That was cool stuff. But
yeah,
if you watch the speed runs where they go through the shrines, not just the shrines in the tutorial zone, the 100% completion when they're going through and basically breaking all of the puzzle shrines, that stuff is cool. They do stuff where they'll jump and then they somehow throw a bomb and then do a shield thing and then blow up the bomb, and they get extra high, and I can't figure out how to do it. I've tried it. And it doesn't
So
work.
it's super hard. Like you have to be really fast with your timing, and you basically have to have brand new like everything just to do that stuff. It's insane to even try. I watched some guys that were like pulling off combos that I couldn't even imagine trying to pull. I was like, what the heck, man? You must have sat there for like I don't know 100 hours doing it straight, just trying to figure out how to do this. But I mean, I know that people put like crazy amounts of time into that game and trying to figure out all of its loopholes and stuff. But I mean, it was a really fun game to beat for the first time. I don't think it's like one I would ever like want to go back and try to do the entire thing all over again. Not to mention it has obviously all kinds of occult symbolism in it. So I just did my one run through it, and then I was pretty satisfied with that. So
I didn't really catch the occult symbolism. Maybe I'm too comfortable with fantasy, but I've beaten it 3 or 4 times.
So you didn't notice like any of like the so all the ancient I forgot what they're called, like the guys you have to get the orbs from, they're all in like what they call they're doing madras, I think that's what it's called. It's like a Hindu form of worship to their gods.
Mantra
so that's
is
one thing.
Actually, that
mantra.
reminds me. I can't remember. I think it was. Oh man, it was the guy who wrote The Rapture. I think it was Ken Johnson is his name. He was talking about. He mentioned Jesus saying, not to pray with many words, not to speak long prayers because they think they'll be heard with their many words.
It's called mudras. Sorry about that.
Oh, mudras. Okay,
yeah, it's
Ken
like
Johnson
they
was
use the
saying
hand
that this
symbols.
was mantras.
No, yeah. It's mudras. If you just look up Hindu mudra, and you'll see what I'm talking about. It has the same thing to do with like chakras, all the meditation stuff. And so if you knew anything about that stuff, you'll realize what I'm talking about. That everything that has to do with that game was like all occultic. But they also have like the one eye symbolism all over the place. And anyways, I'm sure you've probably made the correlation there. There's also the blasphemous Trinity situation there. There's all kinds of stuff that's in this. I mean, again, I'm a fan of the game.
I'm starting to think I don't want to talk to you anymore about. You're ruining Zelda for me.
You're gonna start like hating games, I guarantee. That's what happened with me in League of Legends. Like I used to play that game like crazy, and then I started seeing all kinds of stuff, and I was like, okay, I can't play it anymore. And so
it sucks, man.
It's one of those things for me.
I can't watch just about anything on TV because I just get offended.
That's because a lot of things on TV is offensive, not because you're doing something wrong.
Well, that's why you. I mean, that's why you know that you're safe because.
I quit playing games a long time ago, so I don't have any of those issues.
Hey, we're young. Okay, calm down.
I stopped playing with Space Invaders. Space Invaders. That was the last game I played.
I grew up on video games.
Oh man, you didn't even play like Street Fighter?
I did.
No, nothing. I just quit them all because it's too much time to learn everything, and then you're going to play another game, and then you got to learn another one.
How old are you, Jungle?
Yeah, it was a huge hobby of mine.
62.
For a long time.
Oh wow, you don't look that old.
Yeah, you look like a young jaguar. A cheetah.
Yeah, well, I'm 62.
Yeah, I mean, a jaguar definitely doesn't look 62. Yeah, that's definitely a thing.
How old do they actually get before they pass usually?
Just animals don't live that long, 15, 20 years, whatever. I don't know.
I'm going to look it up real quick. I'm
Well, it
curious.
depends. I mean, like the range is so crazy. Like turtles can live like 100 something years.
Yeah, those are reptiles. Yeah.
Yeah, they can. Yeah. I was gonna say most reptiles they also continue growing. So like if they can live beyond a certain point, then they can basically just be like massive.
Yeah, that was.
I was gonna say
Kent Hovind talked about that. So like, you've got the chameleon. There's a species of chameleon that has like 3 horns on its head, and if it were bigger, it kind of looks like a triceratops.
No way.
That's what I was thinking.
No way.
Why no way? Why no way?
The anatomy. The anatomy doesn't work. It's not. There's no possible way you could turn a chameleon into a triceratops. I'm sorry, I've heard that bounced around. It just doesn't. It doesn't work. Not even enough. I don't care if the chameleon lived for 150 years. It's not getting that big. It's the you don't realize how big these things were. These things are like 30, 40 feet. We're not.
And the horns are
big.
not the same. I think the horns are different too. They're
Yeah,
not the same.
yeah.
I mean,
And
I've
you
only
brought
seen a
up-
couple
I
of
was gonna
chameleons.
ask
My
about-
brother used to have one.
I was going to ask what the anatomical differences are, but as my understanding is
Don't
that
have the
reptiles do not stop growing as
Well,
long
they
as
don't.
they
No,
live.
you're right. They don't. But they have
So
to
if you
live
live
for a
for-
chameleon that is a couple of inches long to make it to the size of a triceratops. The thing would have to grow for like, oh, good heavens, probably 200, maybe 300 years at a decent
I think
rate.
it's possible then.
It's not. It's too much. It's way too, because Triceratops, and you have to remember too, the Triceratops, the ceratopsian kind, there's a bunch of them in there, and not all of them have the three horns.
Yeah,
Some of
but
them have all kinds of
think of
like
it this way:
wacky horns.
I know about the two horned
if Adam died at 900,
yeah, that's
right?
where I was
Assuming that the
going.
flood and everything happened, I was gonna say that just assuming that if Adam, and with a perfect environment, right, everything was living for hundreds and hundreds of years. I mean, you could definitely have large animals like that from just the most basic animal.
Yeah, I mean, we had like
birth there, so-
cockroaches that were 2 feet long. Grasshoppers
Yeah.
of similar sizes
Now,
as well.
guys, just
The
imagine what
radishes.
kind of hero you would look like in front of your wife when you came home and you found her up on top of the bed and a 2-foot cockroach on the floor. Just there
let
are
me get my
benefits
sledgehammer.
for having those things around.
I'll give
Well, I
my
mean-
shotgun, my sledgehammer.
I don't know if a sledgehammer would do it.
I'm not saying that it would be great to have a 2-foot long cockroach. I'm just saying that we find them in the fossil record.
We do.
That's if you could fight off the 3-foot dragonflies attacking you while you're going home.
Yeah.
Yeah.
So, like, if you
Oh,
look
man.
at the size of a dragonfly and you look at the size of the largest dragonflies in the fossil record, is it really that much of a stretch to look at today's chameleons and think maybe they could get to the size of a triceratops?
Okay, yes and no, but okay, you got other problems involved in that, because like the dragonflies of today are very, very anatomically similar to the dragonflies that we find in the fossil record, but the chameleons have significant anatomical differences. Like for example, in tail structure, the tail structure on a chameleon is almost prehensile in a lot of chameleons. You don't have a prehensile tail in a ceratopsian. And the way the limbs are structured, the chameleon limbs almost look more like crocodilian type limbs, whereas the triceratopsian limbs are a little bit more under the body. They do get some like bulge out, but it's not the same level that you have with the chameleon. So there are some anatomical differences, and the amount of time that we're talking about, like. If the chameleon was 4 feet long in the modern world and it only lived for like 5 years, then okay, maybe I could. But the amount of difference the amount of difference between the two is just I don't think it's a plausible scenario, particularly since there are other ceratopsians. If that was the only ceratopsian, then
The chameleons, yeah.
maybe
They climb trees. They climb trees too, and they eat insects.
yeah.
Okay.
Yeah.
So,
And there's also
there's
no
a-
like the ceratopsians have a beak. As best I know, chameleons don't really have that beak structure either. So
True.
Oh, yeah, that's a good point.
so
yeah, but guys,
Could it
you're
be
forgetting
that
about
they
the,
are a derivative, like a species?
I mean, there's a lot of adaptation that would have to take place to get a beak. I mean, you could lose the beak, but you'd have to gain a prehensile tail. Or
So you don't think it's okay? That's fine.
Yeah, I don't think
Well,
it's
how about this,
plausible.
though?
I applaud whoever came up with it for thinking outside the box and trying to make something, trying to see, okay, maybe we can try this, but I don't think it's anatomically plausible.
Yeah.
And I don't think the lifespans would have been reduced by that much to where that a chameleon could get to the size of a ceratopsian, and the fact that there's so many other ceratopsians, and some of them have just like all kind like you're seeing a picture of a Styracosaurus, like that thing's got wild brow horns on the thing. So
do you think that an ancestor of the Chihuahua could ever get to the size of a Great Dane?
The ancestor of a Chihuahua? Yes.
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 The descendant of a Chihuahua? No.
Right.
Not
The
an actual
ancestor.
Chihuahua.
That was my point. Like,
We have a creator.
the question is like how much diversity was in the original form, and
Right, and
is
that's
it
a fair-
plausible to? And it sounds like you still don't think that it's plausible, and I understand it, and I'd probably just drop it. But
No, that's a fair point. That is a completely fair point. And like it's not so much the size like that. I could, if that was the only difference, I could live with it. But the anatomical differences being what they are, and the fact that there's so many ceratopsian members of the that we find in the fossil record that don't match anything that looks remotely chameleon-like, I don't.
Well, I was going to say,
find that
as far as chameleons go, my brother used to own one, and they have these. Their feet structures are designed to be able to grasp onto branches, and so they have like these curled toes on two. There's two of them per side of their foot, and it would be a very different foot structure to the Triceratops from what I've seen.
Yeah, and that's something I didn't even think of, because the ceratopsian toes are all forward, if I recall. So
correct. Yeah, I mean, it looks kind of like it's like an elephant's toes or something like that.
And honestly,
go ahead. Guys, you guys are being all like tossing out freaking scientific names for all these dinosaurs and stuff, confusing people. So I'm just going to have to say that given the fact that a large portion of these are all the result of, artist interpretation, I'm just going to say that the Geico gecko is a prime example of the descendant of insert dinosaur name. And I want you guys to.
True. He's an amphibian too.
Dude,
well, he's obviously
like
the ancestor of a Dimetrodon that lost his dorsal.
Lost his sail.
Ceratopsians just means the Triceratops family of dinosaurs.
I mean, they say that different dinosaurs, were relatively bipedal. So, I mean, the Geico gecko walked around descendant. So, I mean,
Geico gecko is the transitionary form,
and he is
haven't
the
you seen those
result
things?
of an artist's interpretation and amazing CGI. Therefore, absolute evidence of evolution.
I vote for Satan buried those fake bones.
Danny got bored.
Well, I was going to say, clearly Tiktaalik is the ancestor of this gecko. So
we gotta have a serious discussion. Anybody want to talk about the Earth breaking apart 100 years after the flood?
Yeah,
I was going to ask Emery
it's interesting.
if he thought it was possible. Sorry, go ahead.
That I buy the Pangea thing.
There is some evidence for that happening 100 years after the flood.
Why 100 years after?
Well,
you mean
that's
the
when
separation?
That's when the Bible says the earth broke apart. It's 100 years after the flood.
Are you talking about the days of Peleg?
Yeah.
His name means that, basically.
I always thought of it as like he was he lived in the time of the Tower of Babel.
Well, Peleg means
No.
divided. Initially, it means divided, but then in the Aramaic, it doesn't mean divided anymore. It means as the waters flow, which is another clue.
I think that's right. I think all the names have meanings, and of course, meanings can shift over time, and so the scholars are just so skeptical about
it
all
could just be a
right.
It could be a double entendre too.
No, when Peleg was named, it meant divided because the earth was divided, and Peleg was given a name divided in the days of Peleg.
Correct.
Yeah, it may not even been.
I'll tell you.
But then that word divided in the Hebrew changed in the Aramaic. It changed to as the waters flow.
I buy it. I accept it. I think that it is good basis for the argument. So I
Well,
would just ask.
that's only the beginning. That's only the beginning of the evidence. There's a lot more evidence.
Yeah,
Well,
that's what I'm
don't
at.
they
Like,
argue-
why 100 years? Like, so if the
Because
flood
that's what the
was the
Bible-
great,
That's what
Huh?
the Bible says.
So the
Well,
there's
I
the timeline
know.
issue too, though, because there's all the years that came from after, I want to say it was Seth forward. I think they retracted 100 years off of like every patriarch from the genealogy there, moving forward to
Oh,
the
that's-
time where they actually entered Babylon.
Yeah, that's another clue. Another clue is that the lifespan was cut in half by the global flood, and it was cut in half a second time by the Earth being divided. It was cut in half twice. The lifespan of people was cut in half twice.
Approximately.
No, I'm talking about the Hebrew Masoretic text was intentionally changed, seemingly by the Jewish Sanhedrin, probably to throw off the timeline, so that we couldn't verify the genealogy for Jesus.
Well, yeah,
Because they
the-
probably knew that he really was the
evidence,
Christ.
They did that deliberately. Yeah.
The ages are
Yeah.
different
Correct.
for the patriarchs in the different manuscripts. I think the Septuagint versus the Masoretic. But that's something I've
they
been
have
thinking
the
about.
evidence from. Oh, sorry about that. Well, I was going to say, like, they have the evidence from the Greek Septuagint. They have it from I want to say it's Flavius Josephus, and they also have it from the Dead Sea Scrolls, where they were able to verify the timelines were actually off by like 100 years per person, except for I think the last person on the list was like 50 years or something like that.
Which text are they different in? That's what I wasn't sure about. As far as
it's the Hebrew
ages and stuff.
Masoretic.
Genesis, namely.
That's the only one that's off.
From what though? From the Dead Sea Scrolls or what?
No.
Or from-
So the three that are verified true that seem to be corroborating each other are the Greek Septuagint, the Dead Sea Scrolls, and then the account from Flavius Josephus about the original genealogies going back to Adam. So he did like the full annals verification. Go ahead.
Sorry, I might be lagging, and it's causing problems. I'm not sure.
Yeah, not a problem. But that's just what I
we
remember.
can figure it out.
I think I heard that about a year ago.
So,
But then-
Jamie, we can figure it out. When I raise my finger, you raise your finger, and then I'll lower my finger, and then you lower your finger, and then we'll know what the lag time is.
Yeah, but that's if the sound is matched up to the video.
Yeah, it's a two-way speed of light too. You know, you don't know which part's lagging to who.
You
it
guys
depends
didn't
which
get
part
the
of the
joke
country.
that neither of us have our cameras on.
I got the joke. Believe me. I was going to say, I've always found it kind of ironic that, have you all ever heard that song "Wow" by Beck?
Wow,
Sure.
but
It's
Jamie,
a
let's
group
do it.
called Beck. He made a song called "Wow," and in the lyrics, there's a part where he says, "My demons on a cell phone to your demons."
Pretty good.
I always like sat there and like pondered that. I was like, does this actually mean something? Like, is this like legitimate or something?
I think it's funny how they incorporate cell phones and texting and everything into songs that never used
Oh,
to
yeah.
be there.
Oh, I wanted to point out earlier. I don't know if Standing is like awake or whatever, but
Oh,
he
he
was
was left
talking.
behind.
He was talking to David. That's a good point. He was talking to David, and there was a mention of the increase of radioactivity generating a heat problem, but that doesn't follow because he's ignoring the fact that the speed of light has historically been proven or shown to have decelerated over time until we started using what are they called? It's not radiometric. We started using atomic clocks to measure the speed of light.
The problem is we didn't have that in the past. So it looks like it's been changing, but of course the ability to measure has gotten more precise. And so it's disputed. And I think
No. Okay, look.
You
The
can
constant
decelerate it manually.
c is considered a constant. That is the speed of light. H is considered constant. That's the Planck constant. Okay.
Right, they set it
and
into.
Planck and c are inversely proportional. If the speed of light were faster in the past, h would necessarily be lower in the past. That destroys the heat problem. It's gone. It's no worse than it is now.
Yeah, well, we know what the evidence is. The evidence is that it broke apart, and if the animals had 100 years to get where they were going, they had plenty of times to arrive there in every place, Madagascar, Australia, no matter where it is, South America, they had plenty of time to get there.
Agreed.
And
Yeah,
they,
I was just talking about the heat problem, but there is no heat problem.
one of the most compelling things is the glacial markings going from south to north in India. That's one of the most compelling things.
I mean, there's a lot of other things that I think are really good evidences. I think one thing that David Neff brought up earlier, because he was trying to like go on this random talk about like the temperature of like radioactive, the water that has to be used for the coolant for for nuclear reactors. And I'm like, he asked him like, do you know like what the temperature is for the average? You know, I'm like, it's like 900 degrees. And apparently he never responded to it. I'm like, why is this even important? I mean, it really doesn't make a difference, you know.
The average temperature for what?
For a reactor to be fully functional, they have to have coolant that goes through in pipes to keep it low. But so what they would consider coolant was actually extremely hot. It's like 900 degrees for this water that's flowing through it, and that's what we had on our ship. That's the only reason I even know about this is because I had to learn it for my fish calls. So.
Oh yeah,
but it was like I think the exact. Correct. Yeah, there's like exactly. So it's like I want to say it's like 967 degrees or something like that exactly, but I don't remember exactly right this second. But
that's pretty hot, isn't it, for water? That's pretty hot for water.
Yeah, it's just yes, it is. And that's the thing is they're using seawater, which is already extremely cold because we're at certain depths, and so it gets way colder the further down you go. But so that's going from that cold temperature, which is usually I want to say I think it's like negative. What was it? I want to say it's like negative 50 degrees Celsius or something like that. So I don't remember exactly what they
Celsius,
quoted it at, but it gets really cold.
How does it not develop a steam problem?
Or sorry, not Celsius.
Wouldn't it be?
Yeah, I got that wrong. It was not Celsius.
Have steam? Wouldn't there be steam in the water? But like I mean 100
well,
degrees.
They use
well, they're also deep.
Yeah, so they use the steam. They use the steam jungle to allow for the turbine. We have what they call turbine generators.
Oh yeah.
And so that was being pumped through the turbine generators to cause us to have, or to allow us to have power from that one source. We had two of those.
That's the power source.
And they had motor generators. Yeah, it was just one of them. They had two of those as alternates, and then they also had motor generators. There were two of those, and the motor generators were obviously electrical, so you had to have them all running simultaneously. But they would functionally alternate. So like if you had one up and running as far as the TGs were going, then they would have that one only in function, and then they would have to realign the pipes to get the water to flow into the other turbine generator in the event that they had to swap, which they would do that I think like twice a day. It was a really interesting system.
My brother did what you did, but I didn't do it.
Jamie is trying to get back in.
SFT
is mainlining coffee, so he can't.
Wheeled vehicle. I was a
it was an interesting life, man. Oh wow, okay.
Yeah, I was in the army. He was in the Navy. I think there isn't.
I think armies. Sorry, yeah, I think that I'm only catching you at the last second. I think the army has it. I don't want to say better. I think that they actually have it pretty rough, especially if they have to go out into like physical combat. But that's one of the positives with being on a submarine is that clearly, we have the stealth, aspect of things, but if they had the appropriate gear, they could actually track us pretty well. In fact, if they had like a active sonar ability, then they could probably find us really fast and then kill us. So
Yeah. Well, it's hard to know where to be when things happen, but I wasn't I wasn't a grunt. I was just a basic mechanic, and
right.
And
Kind of
it
like a
was
CB.
in the Reagan years. We didn't have a war. He bombed Gaddafi when I was there in Germany, and the space shuttle blew up when I was in Germany, and Chernobyl blew up when I was in Germany.
What kind of rigs did you work on?
I worked on just diesel trucks and gas trucks or diesel trucks, whatever. Wheeled vehicles. That's what I worked on.
I used to do that for a while too. I took schooling on that.
Deuce and a half, 5 tons. I cut the tip of my finger off on a 5-ton transmission.
Dude, we're like brothers, buddy.
Oh man,
I cut my finger off too.
It's just the tip of my finger, but it grew back.
Mine didn't.
It surprised me.
That's a miracle, man.
Yeah, I didn't. It was only the tip, but the very tip, and I'm trying to get it to heal back, to grow back on, and it fell off, but it still grew. Yeah.
Oh wow, man.
That's
Jamie.
You didn't.
Jamie, you're missing half your ring. What happened to you, man?
Did you put your finger? You didn't put the finger all the way in the hole, did? Is that what happened? That's pretty much.
Oh no! What happened?
I was like 17. It was a long time ago. It was wood shop.
Oh, wood shop.
Oh, table saw.
Yeah.
Wow, man. My dad's a carpenter, so I can relate with that.
Yeah.
Although I haven't cut my finger off. Well, thank the Lord that you didn't lose anything else, man. That's amazing.
Because I was feeling for the hole to put the bolt in, and the thing, the transfer moved, and then it just cut the tip on my finger.
You snipped it right off, huh?
Oh my God.
Laid it right off.
Yeah, cut it right off.
Jamie, like it may be gone by now, but after that happened, did you ever have sensations?
Phantom pain. Phantom pain.
You had that?
Yeah, not real bad, but like when you lose a leg or an arm, it's real bad, I guess, because of the nerve pain, the phantom nerve pain.
Phantom pain.
Yeah. So, basically, the whole middle section of that ring finger on my right hand got totally just kind of ground up because I was using a dado. So it's like 6 blades stacked left to right. Because I was cutting joints for 2x4s, like just the same thing on really short boards, and you kind of pass it through and then you pull it back through. And the teacher decided to take the guard off because I was pretty capable. And then they were like 16-inch boards, and I was doing like a lap joint on each end, and I was making so each framing was 4 pieces on each end, so it's like 8, and then I did like 16 of those frames. So I was literally doing it all day. And you had to pass it through like maybe 4 or 5 times to like clean it all out real quick. And I was kind of sick that day, and then it was a full class, and some girl and I was stacking them up on the table saw, and a girl screamed like bloody murder, and it like distracted me. I looked up, and they were just goofing off. And when I looked up to see what the noise was, I kind of half stepped off to the one direction or whatever, and then as soon as I realized nothing was going on, I just kind of went back to what I was doing, but I kind of shuffled over a little bit, and I just went to set the board down, but I was shifted back towards the saw, and he had taken the guard off too, so I basically just set, I wasn't cutting when it happened. I was setting something down, and it just caught it, and I threw my arm back. First moment it happened, my arm was twisted behind my back basically, and It felt like when you hit a baseball with like a metal bat and you hit it wrong, you know, you get like that vibrated feeling.
Wow.
And I looked at my hand and I just instantly looked away. I didn't even really see it, but I knew what it was going on. And I like calmly walked up to my teacher, who was like a giant, by the way. He had that really deep, giant-y voice and hot dog fingers, like he's a big guy. And I said, hey, I cut my effing finger off. This is like a private school, right? And he didn't really hear me because it was loud. And so he said, hold on a second. And he turned back to helping the student, some girl doing some cut. And I just patiently stood there with my hands behind my back. And then like literally he took like 20 seconds as I'm just standing there, like blood is like pouring on the ground. And he says, now wait, what did you say? And he like kind of leans over to me. And then I just pull my hands out in front of him and show it to him. And his eyes were like saucers and he turned white. It was so crazy. But yeah, the pain, it felt like little needle pokes in my cuticle. That's all I would really feel. And I still get it once in a great while. And it feels distinctly in the cuticle. But the tip of my finger too, it was like perfectly intact. Just the middle joint was gone. And like, I guess it like flew across the room and this other guy picked it up and put it, like wrapped it up. And they sent me to the hospital. And you know, like in movies when you see a hand or something in a jar, you know, with like fluid, it looked just like that, totally fake, like floating there in the bag. It's crazy. Anyways.
Wow, man.
So to be totally,
if anything,
ignore your pain, I would say I think it's ironic that you have lost a finger and have felt phantom pain, yet still think that your body and your soul are the same thing.
You're right.
I was going to say that wouldn't that make an? I don't know. It feels like you should actually be a dualist, just because you can. But
right?
Imagine that like your soul really does have that finger still there, and you just don't realize it. You just can't see it right now.
Yeah, I mean, yeah, kind of. I mean, it's like I would say it's like just your pathways in your brain. You know, it is a weird phenomenon for sure, but you know, I mean,
your soul. It's your soul thinking there should be a finger there.
Right.
He like flicks the space where the finger used to be, and he feels something.
So, are you denying that nerves are actually a thing, or what?
I deny everything.
So that would be the question. I would say, if anything, that would be like a reason to doubt a soul or something.
I don't deny nerves, but if your nerves are canceled, terminated at a certain point, I don't see why your body would sense sensations beyond where those nerves go.
That's the thing that's strange.
Yeah, it's strange either way.
That reminds you guys. You guys have got to see this shirt that my wife got me.
See it.
So I'm gonna try to get close enough.
You need to move a little bit. I can't read the chat box.
Yeah.
The other way.
Sorry, it's hard to get that way.
Can you read it? What's that say?
And that's how I saved the world. I see the Hulk.
He's got all the
Avengers,
Hulk and
right?
Superman.
The Avengers.
What?
They're all there.
What is that's Marvel and DC mixed up? What kind of crazy comics do you read?
Hey, hush. Okay, calm down. The whole point is that he saved the world and they didn't. Okay, it's the whole point. They had to try and they still failed.
I don't even understand this universe. The Hulk and the Superman, right?
What better characters could be right next to each other? Come on, they has so it's got Iron Man, Hulk, Superman. It's got let me see real quick. So on the left, it's got Captain America.
I mean, dude, it's like Frodo sitting next to Harry Potter. It just doesn't make sense.
I don't care. I don't care. I don't care. He's just giving them the gospel, bro. He's trying to save them. Can't you just deal?
It's a wonderful shirt, Matt. It's beautiful.
Thanks, man.
It's just nonsensical.
As if any of that's supposed to make sense.
So how about entertaining the idea that Europe is Semitic and the lost tribes of Israel, with the exception of the RY chromosome that's prevalent?
I have a view on that.
All of
I
you?
gotta see that stuff.
I suggest that is an artifact of misinterpretation, and this is just speculation, and you can correct me, anybody, but I would guess kind of like how, like in the 90s, when there was some Christian speakers that were going around talking about these bloodlines and stuff of the Illuminati and all that, that maybe that those things are like kind of like 6 degrees of Kevin Bacon sort of thing, where we're like, we didn't realize it. And it seems like it's kind of coming out, though, in the sense that like even the evolutionists are like when Swami Das admits, like, well, actually there's evidence that we're all like directly related to like a very limited set of human ancestors, you know what I'm saying? Like, which is actually better evidence for our side, but that we're actually so closely related because the common literature of the science on this has had assumptions of evolution, and so they make things seem like makes it look like people are more related than when we're all really more related.
If you look at the mitochondrial,
we're genetically proven to be.
If you look at the mitochondrial maternal lines, the DNA is almost all Semitic in Europe. It's almost all.
But what defined the Semitic in the first place? For them to say that.
No, I'm talking about the mitochondrial DNA. You can tell that what's Semitic and what's not, and most of Europe is all Semitic mitochondrial DNA.
I'm just wondering, like, what set the standard for what is Semitic, like, meaning Semitic, like who else? You know what I mean? Does anybody get what I'm saying? I'm not explaining myself very well. I'm just
You're basically saying how do they specify or pinpoint that this is the Semitic gene?
Yeah, and I'm not even trying to challenge you, Jargon. I'm just throwing speculation out there. Like, what's the difference? Maybe SFT.
Well, because you can tell that the Jewish population, what's prevalent in the Jewish population is one tree, and then what's not is the other tree. So the L's, if you're familiar with mitochondrial DNA, is the African DNA. The M's would be the Japhethite wife DNA, and the N's, so it's LMN, the N's are what's prevalent in the Jewish population, and it's almost completely the N's that's in Europe, not so it's Semitic and what is present in Jewish populations in Europe, and not Japhethite.
Is this supposed to be like correlated? Is this supposed to be correlated from like the Shemite line? Is that what you're saying?
Yeah, that's the Shemite line.
They've been able to pinpoint that.
So it'd be the wife of Shem.
So the idea is that they're more related to the Jewish population than other non-Jewish groups, or are you saying that? Or is this saying that like they're more closely related to the original?
Yeah. So in
the
Europe,
word Semite came from Shem.
So in Europe, there's not hardly any percentage of the M as in mom, maternal line DNA, which would be the non-Jewish mtDNA. So there's hardly any of that in Europe, and there's a lot of what is in the Jewish population, which would be Semitic.
I think these are interesting questions. I'm trying.
One of these days, I would love to talk to Jungle more about it, because I find this stuff kind of like.
But it's
confusing.
not the only. Yeah, it's not the only evidence. I don't know if you've ever heard of the Scythians. The Scythians, and there's other groups that were known to be the 12 tribes or the 10 tribes of Israel that went north or that were taken captive north, and they were settled in a certain area right underneath the Black Sea, and they made it through the mountain passes, and they went into a place where the Scythians are known to have lived, and then from there they went throughout Europe, and then the step RY chromosome kind of like invaded Europe, either before or after, whichever one came first.
Huh.
Yeah.
What do you think the implication would be? What is like why? I know that I think this can kind of get to like some ways that Christians look at these things differently, and I'm not saying you're any certain way at all. I don't know, but something I've been thinking about that this I think of it essentially you end up asking, and that is like I've often wondered, like, well, like to be Jewish, people like to say they're Jewish or not, or they are, maybe they are, and this is probably just my ignorance, but I just wonder, like, is there a certain point where you no longer say you're Jewish, or do you just have to have some part of you that's, like a percentage of quote unquote the bloodline or whatever?
I haven't ever considered myself Jewish except for this evidence that most of Europe is Semitic, and largely even the IY chromosome is throughout Europe, which is the Scythians. But I do have a great grandfather that was Jewish, probably from the Caucasus Mountains or something, and that's why my nose is the way it looks, probably. But because most English or Scottish or whatever have a smaller nose, and it's kind of like straight and not crooked and not whatever. It's not as big.
It's a recognizable
So that kind
feature,
of explains my nose. But I never actually considered myself Jewish in that respect. But then when I come to find out that I'm probably Israelite, especially with the IY chromosome and the H mitochondrial DNA, which most of the Europeans have, the HY chromosome.
That's
like
interesting.
over half
guys-
Europeans.
Well, I mean, technically speaking, what's that?
Well, I was just gonna say that and I was watching a video from Inspiring Philosophy today about the Philistines, and he was making a point, and it was something I've been thinking about too lately, just in the relation to these questions. Like, the Bible obviously didn't know about DNA, and I'm not denying that God can't like foreknow things in the future and like design the Bible that way on purpose. I think he does.
God
do that,
made
but
DNA.
But my point was just that, like, when the Bible talks about Philistines or any other group, there seems to be, it doesn't seem to be making a distinction about like genes that way. I mean, other than like general points, like we're all related, because of the way the story is. But like, I think oftentimes, like, it might be like, it'll say like the land of the Philistines. It's just, it wasn't necessarily like making a point on like your line per se in all those distinctions. Like, sometimes it may have just meant like, well, where you come from.
I mean,
or like
clearly.
But weren't they Canaanites though? If they're Canaanites,
right, some of
they
them
would
were,
be...
but some of them weren't. There's indicators that
right,
they're,
of course. There's mixing.
and then also, just one last thing, and I'll shut up here. But the other thing about that was interesting was, oh crap, I lost it.
Okay,
Because
well, I gotta go to bed. So
the Canaanites.
it's 3 in the morning
Okay,
here.
Bob.
Yeah. God bless you guys.
God bless you, Bob.
LPP isn't here, so he can't chastise me after I leave. The gospel by which you are saved is that Christ Jesus died for your sins, according to the scriptures. He was buried, and he was raised from the dead, according to the scriptures. Right.
All right, God bless you.
God bless, man.
Repent and accept the gospel. Praise the Lord.
Believe the truth. Only your creator can recreate you, nobody else can.
Absolutely. I was just going to make the distinction real quick that clearly, if we're going to do this by like the genealogical lines, I think you have to mark it from where Abraham starts moving forward. and then you could say that people are like Semitic or not from that line onward.
Sure, yeah.
But I agree that
Well-
Shem obviously is the line that he came from. But see, remember, God made his covenant specifically with Abraham.
We know who we know the Arabic population Y chromosome. What's more prevalent or most prevalent among the Arabs? It's a J1 Y chromosome, and the Jews are J2, and Israel is I.
Oh wow!
It's kind of fun.
Oh, okay. Yeah,
And
that's what I was going to say. Is what about the
Cushites-
mixed multitude that came out of Egypt with the Israelite or the Hebrews? Would that?
The Jewish population does have E1B1, which is probably the Canaanites or some Egyptian or some early Egyptians, maybe.
Something that came from that time period
They-
that may be involved with that.
They do have an EY chromosome, they have a TY chromosome, they have a GY chromosome, and the J2Y chromosome, and the I2Y chromosome, and of course, I believe the I1 is Israel too.
I got to see this research, so
Because
I'm on
it's
the same page with you.
it's all the same tree. It's all branches on the same tree. See, in other words, the EY chromosome is a branch from another tree.
Right, I get that.
The T is from the Japhetic tree. The G is from the Semitic tree, but it's not necessarily Abraham. That's the
Okay.
Y chromosome. But in the mtDNA, it's almost all Semitic.
Is Danny
So
still
it-
here? Is he?
So they do share
I'm here.
even the Jewish DNA that's found in American Indians, because they did go all the way to America, is the same traces of DNA is the GY chromosome, the TY chromosome, the J1Y chromosome. In fact, there's a large amount of the J1Y chromosome, which is Arabic. Then there's the J2, the I2, and the I1Y chromosome, all, showing a signal in the American Indian population. Not to mention that there was a separate RY chromosome that made it to Europe. Made it from Europe to the United States or the Americas as well.
All right.
And believe it or not, there's a trace of the EY chromosome and the BY chromosome, which is Hamitic from Ham or African.
Right.
Of course.
Okay.
So Ham had 4 sons, right? He had Put, which is supposed to be the father of the real Phoenicians. Later, there was a mixed group that was called Phoenicians, but they were like mixed with a whole bunch of people. But Ham
Are they the Greeks?
had Canaan. I think the Greeks are pretty much Semitic. Ham had Canaan, Put, Mitzrayim, and Cush. Those were his 4 sons. And to this day, there's the Cushites in Ethiopia. There's, of course, Mitzrayim in Egypt, and there's the Berbers in North Africa, which are all E3, apparently, or close to it. But the E1B1 seems to have been either the Canaanites or the early Egyptians or something. And they actually did a DNA test on some of the pharaohs, and they came out, at least one of them came out an E1B1, which is African Egyptian. But then King Tut, do you know what the results of King Tut's Y chromosome is? It turns out they took his DNA, but they didn't want to share it with anybody. They didn't tell anybody, but they had the sequence published, and so somebody in Europe, I guess the Switzerland somewhere or Sweden somewhere, they ran it through the computer for the DNA, and it turned out to be an R1B1. In other words, King Tut was had a European Y chromosome.
Wow. Okay.
which is neither Semitic nor Hamite or Hamitic.
Wow.
But it's very
Hey,
interesting
Danny.
because the Y chromosome is branches off from the Q, which goes east, and the R goes into Europe. The R is the steppe people, the steppe grassland people that kind of like moved into Europe. They brought the RY chromosome into Europe, and
Okay.
that's the majority Y chromosome in Europe right now is the RY chromosome, which is confusing because it's the same thing as the Q, which is Oriental. So there's clearly some autosomal influence going on from the Semitic population in Europe.
I wonder what they tracked down for like Native Americans from the lineage, because I mean it's funny. My wife, she did a genetic test, and it turns out that pretty much all of her ancestors came from like Central and South America, and
yeah, that's cute. Mostly
there was
cute.
no like evidence that there was like Oriental genetic information in it.
I gotta double check with the mtDNA. I think there's some Semitic that went all the way into the Americas with the mtDNA. But as far as the Y chromosome is concerned, it's mostly Q, with the exception of C, which comes from Nimrod. Nimrod was the son of Cush, and his descendants never went to Africa. They went east all the way to the Americas too, as well. So there's a mixture of C and Q in the American indigenous population, mostly. But it mostly Q all the way through America in the Y chromosome. But then the mtDNA is, I think it has Semitic in it.
Okay. Danny, because I'm slightly competitive, I would like to know what was your best KDA on League of Legends and with which character?
KDA? First of all, can I be heard?
A little bit.
Yeah, I can hear you.
Is the audio now?
You're like pretty low, yeah.
Is this bad? Is it? Oh my gosh.
Better.
Okay.
It's a lot better there.
I mean, I played thousands and thousands and thousands of games, so I don't even.
Yeah.
You know,
here.
because like the problem though is that having a KDA.
What's the one that you remember, man?
Well, I don't really. I'm not a KDA. I mean, I've had like 35, 40 kills before, but like with lots of deaths. The point is that, as you know, I think if you watch professional play, the kills and deaths are not very high. Why? Because
yeah.
The point is that
it's
if you have a lot of,
I know.
Yeah, because like it's a 6-1 KDA could express that you played better than if you were like 35-10. It's kind of like
technically. I mean, I think so. If you're like a one man, basically like 1v9, then I could expect a game where you're like going like 40. Because I went 46-10 as Fizz one time, and like that was basically the iconic game I had. I was like, oh man, look, I can show this game off for people, But I mean, I've had several games where I was playing Kazakhs or other various characters and just getting like really crazy KDAs. But I don't know. It just depends on who you're playing, I guess, in the type of game that you're having to play.
Yeah, I play. I mean, I kind of like. I've largely ignored KDA as a relevant stat, except for when I'm like what you said, showing off or playing with friends.
Well, it does obviously bear relevance. What's that?
You see, I don't think so. I think that. I mean, I think the game is not about KDA so much as about objectives.
It is about objectives, but if you have like so if you have a character obviously that's feeding, then that's clearly going to give them an advantage, right? So, like that's one of the biggest conditions I always had whenever I was playing ranked matches was like whenever I had like played support, I would be literally the only person that would have to go in and like save somebody's butt every single time. And so, I mean, if you ever had somebody that was just like straight up like playing top to fall, You ever had a Trinamere that would try to like do no damage and
Of course, yeah.
like try to take all towers? Yeah, like I've seen that happen like in a ranked game. I've seen like, you know, the teamo that just sits there all game and just puts a bunch of shrooms there to protect his towers, and that's all he ever does. I've seen like there was all kinds of ridiculous stuff, but sorry, I'm getting like way off topic for this conversation.
Well, we gotta.
Sorry, I'm finishing up my paper. That's why I'm not been participating very much.
We gotta involve Danny
not a
somehow
problem.
into this Y chromosome conversation or something.
I was like, because I don't even know how far like I can really get into that without actually understanding what's happening. So, hey Iger, though, that tree, is that really a tree or is that just like a mountain?
No.
I don't really know.
No, they say it's a tree, but it's not a tree. It's just volcanic rock. Volcanic.
Oh,
whatever.
okay.
It's like there was a volcano there. The rest of the sediment got washed away and it left the column. Go ahead, Iger.
Oh yeah, this is Devil's Tower. Has hexagonal columns. When you watch lava flow, it flows not forming upright hexagonal shapes. So even if you look at the website,
Which is common with volcanic.
Even if you look up Devil's Tower and how it was formed on Wikipedia, it says the best theory now is what you call basalt columns. But you got these hexagonal shapes, and you got the Bible talking about ancient big giant trees, and plus the Book of Enoch talking about giant trees, plus just about all of mythology talking about giant trees. So it makes more sense that in the flood there was a lot of trees that were petrified as the waters were washing away and everything was buried.
Yeah, if you think about it from that perspective, technically that could be a much, much bigger tree, and they could be like, you know, hidden in layers of sedimentary rock.
That's my thing now is the giant trees. Especially the ones with hexagonal columns.
They think that still remains of a tree that was standing up, apparently.
That's right.
That would be crazy.
You would say,
Can you imagine how big that tree would have to be?
Modern secular scientists would say that it was lava that flowed up perfectly, forming hexagonal shapes.
Yeah, because that's a common formation.
That's because there was giant trees.
I mean, just looking at the picture. So obviously we're men. We're only going to probably be, I don't know, come up about.
I think it's narrowed. I think it's narrowed a bit. I think they kind of like squished it to make it look like a tree. I don't think it's that.
Devil's Tower. I literally looked up this image from Google, the Devil's Tower, and this picture somebody sent me. But either way, man, it doesn't matter. But yeah, my last upload was about giant trees. If you want to check it out, it's 6 minutes long on Iger Television on YouTube.
But it really doesn't have tree rings, though. That's the thing.
I don't know. I haven't seen any good pictures of it from up top. But what's puzzling is the hexagonal shapes, columns. And
that's a common volcanic formation. In a time of the flood, it was a common volcanic formation.
You would say it's a perfect lava flowing and solidifying itself into hexagonal.
Yeah, it crystallized in those forms. Yeah,
as opposed to it being a tree that got petrified.
Yeah, because there's no, I mean, you can't see any stem holes or anything like that, and it's just a common formation.
We don't see lava forming into hexagonal shapes nowadays either. So
not today, no.
Of course not. So
because that was.
But what does the Bible talk about giant trees?
Not that I'm aware of, but that had to have happened with the huge forces from the global flood. Oh, somebody's breaking up.
Can you say that again?
Does it not live by
I don't think.
I agree. You're breaking up real bad, man.
I don't think the hexagon shapes are.
Yeah, I'm gonna go in some guys. My internet got act up around this time, so it's about that time, bro.
I don't.
Sorry, I didn't talk much today. I was
Alright.
enjoying your conversation with Pigs Can Fly. Jungle, it's always nice listening to you. Standing for truth as well. Danny, it's nice to have you have the opposition side over here all the time. That's always nice, because if not, we'll just be talking to each other and agreeing for the most part. So it's nice to have opposition. So you're always welcome in my channel, Danny, if you come in.
Oh, I didn't know you had a channel.
Yeah, I'm on Instagram and YouTube, and but my last upload on YouTube was about giant trees. If you guys want to check it out, it's 6 minutes long. There's like Jungle said, we got these formations all over the world. They're hexagonal shapes. They're neatly tight packed into each other. You can pick a smart lava if you want, but we don't see lava forming like this ever.
Not today, no.
So it's not considered science if we can't replicate it and demonstrate it. But it does look like the trees we see today.
Except that.
All right, guys, have a good night. God bless y'all. Love you, and
There's long.
you'll have a good day.
There's long cliffs made of it.
Have a blessed day.
Yeah, my internet's horrible today, man.
Sometimes
Jungle,
mine is too.
me and Jungle gotta do a debate on this topic. My best video.
Yeah. Okay.
All right, y'all. Have a good night, man. I'll
All
catch y'all
right.
tomorrow.
Man.
Peace.
See.
All right, guys, I'm jumping in here. We're going on 3.5 hours. And this guy's got to get a little bit of sleep. I got to say, enjoyable discussion. You guys always keep it fun. And any last words before we shut it down? You guys are always welcome on the channel. Danny, I always appreciate your input.
Oh, wow.
Nadia,
Listening today.
What's that, Danny?
It was good simply listening today. I was writing a paper, so I couldn't really participate.
How's the paper coming along?
Oh, it doesn't flow at all, but so we have a lot of work to do.
Hey, listen, you're an intelligent guy, so I'm sure you'll be acing it, Danny. So don't even worry. All right, guys, I'm gonna go get a little bit of sleep, and always a pleasure. Everybody in the chat, I hope you guys had a good time. Tomorrow night we've got a debate on the Gospels, timing of the Gospels with Gavin and Jefferson. So that'll be at 9:30, I think it is. 9:30 EST. So we'll see you tomorrow, and I'm sure there will be an after show where we can go on for another 6-7 hours. So everybody, God bless. Thanks for joining. Pigs Can Fly. Always a pleasure. JJ and Danny, guys, take it easy.
All right. Good night.
God bless you all. Have a blessed night.
God bless.